I think we're starting. Hello, everyone. Welcome, 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 wherever you are. Welcome to our STEM Net Zero event brought to you by the good people. Well, we've got a lot of people, actually, I want to thank, actually. RTC, of course, STEM Hub, Research England, Durham University, Teesside University, etc., etc. We've got a jam-packed day today. We've got some fantastic speakers who are going to be talking about all different aspects of STEM. I just want to say a few thank yous. First of all, to the Research England Hydrogen Innovation Project, REHIP, who have kindly sponsored this event. REHIP, for those of you who don't know, is all about hydrogen. How can hydrogen help us in achieving our net zero goals? And there's a lot of talk about hydrogen, particularly in the northeast of England. Really amazing stuff. I've been really lucky over my career. I've done lots and lots of films for television over the years. And a couple of years ago, I went all around the world looking at how hydrogen, this gas, the most common gas in the entire universe, can be used as an energy source to help get us to net zero and help us solve some of these problems with climate change. We're going to be exploring that a little bit later on. Let me just take you through the day today. So first of all, 9:15 to 10 o'clock, we have got Steve Bunce, who's going to be here, talking about how technology helps us save the planet. And this is going to be a recurring theme throughout the day, looking at the technological solutions for climate change, for sustainability. How can we use technology in a creative way to get us to net zero? Net zero, of course, is incredibly important. Climate change is an existential threat, if you like, to everyone on the planet. We're really concerned about how much CO2 particularly we're putting up into the atmosphere. So how can net zero help us develop clean energy? And the other problem, of course, is with things like AI, we're increasingly using more and more energy. It's not just how can we solve the amount of energy we're using now, how can we make that cleaner? But of course, we're going to be using more and more energy because AI is incredibly thirsty when it comes to energy. So we need lots and lots of creative solutions, and that's where that comes in. So why is today important? Well, of course, thinking about creative solutions to energy it's important, as we've discussed. It's also really, really interesting. The story of how we do it is absolutely fascinating. And our speakers today, I know, are going to have lots and lots of hands-on activities for you at school to be doing, which hopefully you will enjoy. The other thing as well, important, it's interesting, is thinking about careers. Lots of you who are going to be leaving school soon are going to be thinking about, well, what is it that I want to do when I leave school or go to university? And actually, a career in engineering, thinking about some of these solutions to our STEM net zero goals is a really, really fantastic thing to think about. And so there'll be lots of advice throughout the day, getting you to think about how that might happen, courses available, jobs that are available too. So that's what we've got to look forward to today. I'm just going to go through some of our speakers. So 9:15 to 10 o'clock, we've got Steve Bunce. He's going to be talking about how technology will help us save the planet, which is going to be excellent. 10 o'clock to 10:45, we've got Meryl Batchelder, who's going to be looking at biomimicry. Now, I think biomimicry is absolutely fascinating. If you don't know what biomimicry means, it's basically looking at how nature comes up with its own solutions. So things like feathers or well, all kinds of things, that eyes, how nature is a kind of design algorithm, if you like, and how we can look at nature and actually copy what nature does for its solution. So that's going to be absolutely fascinating. I'm looking forward to that. That's at 10 o'clock to 10:45. And then at 10:45, this is exciting. We've got an escape room for you to do, an escape room with clues that you can follow. And there is a prize for whoever wins the escape room, I think. I'm not sure what the prize is. Maybe it's £1 million. I don't think it's £1 million, but it'll be good. So that'll be fun. So that's at 10:45. And it's a kind of video escape room thing that we can do together. I'll be sort of leading you through that, as it were. Now, 11:30 to 12:15, we have got our hydrogen session, looking at hydrogen. What is hydrogen? How can it help us get to net zero? How can hydrogen be used as a fuel? And what careers in fact, are going to be available in the world of hydrogen. Now, at 1 o'clock to 1:45, we've got Tracy Johnson and we've got Laura Baines with Balfour Beatty, and they're going to be talking about carbon capture. This is a really interesting thing. So, of course, if you're a power station and you're putting CO2 and other emissions up into the atmosphere, is there a way that we can actually capture that carbon and actually lock it up so it doesn't escape into the atmosphere? And carbon capture and storage is, of course, a thing, but we're going to be looking at the future of that. How can we make it work? We've got some really good examples of that and things for you to see and do. 13:45, 1:45 to 2:30. We've got a maze lab with Leonie Briggs, which is a primary school event. This is going to be good. How glass plays a vital role in achieving a sustainable future. We're going to be looking inside a glass factory and seeing how that works. So that'll be fun. 2:30 to 3:15, we've got Ruth Amos, who is going to be looking at how creativity and engineering can change the world, and there'll be lots of hands-on things for you to do there as well. So lots and lots of different subjects, all connected to this idea of STEM net zero. What does it mean? What does sustainability mean? What is climate change? What's it all about? There's going to be plenty of time as well for you to explore things with your teachers in your classrooms, but also lots of opportunities to ask questions to our speakers as well. And I'm going to be moderating throughout the day, so linking all the different speakers up. So if you've got questions, I'll see the questions and then I'll be able to ask the speakers, or if they're questions that I might know the answer to, I might actually answer them myself. So there you go. So I've got them coming through on WhatsApp on my phone. Let me just check that that's working. Yes, it is. Great. Okay, fantastic. Right. Okay, we're going to go to our first speaker. It is Dr. Steve Bunce from the Royal Grammar School, and I'm going to hand it over to Steve, who's going to be talking about how technology helps us save the planet. Steve, are you there?
Good morning, Dallas. Good morning, everybody. Welcome this morning.
You look very colourful and Lego based in your wherever you are. I like this.
I am. I'm based here in Newcastle today, and you can see that we do have some sunshine. It is looking like a good day's coming. It's nice with the autumnal day coming, so we're all good for the weather. But that may not be good for solar panels, though, as we shall think about. Okay, so I'm just going to spotlight myself here on the camera just so we can all see it. There we go. Spotlight for everyone there. Okay, so hopefully you can see me here on the big screen, and if you want to maximize that to the screen, I'll be playing everything through the camera here. And today what we're going to need is we're going to need an A4 sheet of paper. So if you have some paper there, or we're going to go and quickly grab some, we're going to need an A4 sheet of paper this morning in our session, because we want to get those fingers and those brains going. Okay, so an A4 sheet of paper is what we shall need. Okay, so I have mine ready. So today, what we're going to think about, as we said, was how technology can help save the planet. And it's my lucky role here this morning that can set us thinking off for the day, as we're going to hear all those wonderful things Dallas has just been mentioning about the other speakers that are coming on the camera later. So how technology is going to save the planet. So that's a great question, isn't it? How is technology going to save the planet? So we're going to think about this through the idea of us working together as a team. So I'm going to mention some different roles we can think of, and you may want to think of some more roles that might be involved in that. Okay, so how technology can help save our planet. Okay, so if I swap over here to the screen there, you can see that's our theme. You need your paper. Don't forget to get your paper. And then we'll get going. So this morning, we're going to think about, in our short talk, about how robotics and AI and data collection can work together. And what we're going to do is we're going to try out some different ideas. So today I'm going to demonstrate some things like, how to use a microbit, or how to use, for example, Scratch. So hopefully tools that you've used before. Maybe you've used them in your computing lessons. We thought about how you can code using blocks of code in Scratch. So I'm going to demonstrate a couple of ideas this morning that then you can go off and try out yourselves. Okay, so we are aiming towards net zero, and that's today's thinking. Okay, so we're thinking about net zero and how we can try out and think about that. Okay, try and think about aiming towards net zero. So to think about it in simple terms, we could think about it a bit like this. There's our planet. We want to look after our planet. And there's pollution coming in. Okay, so we've got our planet, there's pollution from cars and factories, and they're creating lots of greenhouse gases. We hear about things like carbon dioxide. And then what we want to do is try and reduce that, because we know that's warming the earth, it's causing global warming, it's causing different problems. So we want to think about how can we use maybe technology to reduce energy that we're producing these gases and use smart technology. Switching over to maybe cleaner energy, and we have just nearby here in the northeast, we have things like the Blythe catapults, where there's loads of great stuff going on, researching about renewable energies, using tidal energies and all these different things. How we can try and use those renewable energies to try and reduce our energy uses or find better ways of producing energy without producing those greenhouse gases. And then we can think about, once we try to reduce the energy use and switching to cleaner energies, maybe we can also think about how we can capture. So thinking about how we can capture those gases by, for example, planting trees and other ways of carbon capture, through wonderful things like mushroom roots, mycelium, using that to try and help capture carbon. And therefore, we can aim towards net zero, the amount of energy and needs we have, but also the amount of gases we're producing is balancing. Okay, so we're trying to do that balancing. And if I dare try and do this motion for balancing, I know other people will be doing different words to me, but I'm thinking of us balancing the two things, so that we don't have, for example, 6 or 7, but actually, equal amounts. So let's get going today. So thinking about that idea of net zero, how can we then, for example, get our team together? Who are going to be the people in our team? Well, we could think about these 4 people today. You might identify with one of these people, or then again, you might think of your own role that you want to be in the net zero team. Okay, how can we get these things together? Today we have, for example, a solar genius, a robot ranger, a nature protector, or a data detective. Okay, so we could think about these different roles and how they might help us achieve or head towards net zero. So let's start off with our friend, the solar genius. Okay, so we've mentioned about how we could start to think about getting towards net zero by using maybe renewable energies. So we can think about the idea of solar energy, or we could think maybe, well, today's not, maybe it's not a very sunny day today. The sun is out, there will be some energy generation. I know it's a windy day, we could use wind turbines. But then again, maybe it's not a windy day. Oh, it's okay, because the sea is there, and the sea is there with its tide, and we could maybe get the energy from the sea. So there's all these different ideas. And also today, you're going to be hearing about hydrogen and how hydrogen maybe is a way forward in terms of our creating lots of energy, but doing it in a better way for our planet. So our first role could be our solar genius. And the solar genius might think about solar panels. And actually on this photo, if you can see this image clearly, you can see that it's got actually a robot on it which cleans the solar panels. So it's not as simple as just getting the solar panels and putting them out in the fields. And again, in the northeast, as you're traveling around, if you're traveling across towards the Lake District, you'll see a huge solar farm being erected over there. And also over here in the northeast, we've got large solar farms being built. But actually, you've got to keep those clean. Think about it a bit like if you were having a house and you've got dirty windows in the house because they get dirty. You need to clean the windows of a house. And sometimes maybe you're in the classroom in a school and you'll be there and you'll be busy listening to your teacher, and then out of the corner of your eye you'll see somebody cleaning the windows, and you can see them making the glass nice and clean again. Okay, so it's thinking about that. The solar panels are great to generate that electricity, but also we need to think about how can we keep them clean. So one of the things is the idea of a robot which can clean the glass, clean the solar panels. Okay, here's a different type of one which rolls around, a bit like, I suppose, if you see those vacuums in the house which can vacuum up and automate doing the vacuuming. Okay, and here's another one. Okay, it's a different design. So maybe not only are you thinking about you're going to be on the solar genius team, but you're going to think about maybe how could the robots help us with that. So with robots in mind, what about a robot ranger? Maybe you're thinking you might want to be a robot ranger. And in school, you might be doing loads of great stuff with robotics. We do things like the Lego. We have the first Lego League, and we have all our Lego. Or maybe you do other robots like, oh, like the Sphero robots. So these are great robots which you can use, and you can charge them up and light up the lights and program and code them. So you might be doing some robotics in school already. What else could we be doing? Well, we could think about the robots in our factories. So this is a general idea of, in the factory you have like a robot arm. It doesn't look like a human, does it? It looks more like just a simple arm moving around, but it's a very complicated process. And the idea is this could be more efficient. So that might be saving us energy. We're trying to save energy to make ourselves get towards net zero. Here's an example from Nissan. So just near Sunderland, we have the Nissan car plant here in the northeast. And there they are using those robot arms to automate processes. Not only can they make it more efficient, but they can capture the data to try and improve those processes, to think how they could use energy more safely. And here's another example from the northeast. This is called iCart. And this robot is a simple robot arm. It can go around. Maybe it could be used to pick things up, or it could be used like a camera to go and see things. And you can see on the bottom of it, it's actually just a simple, well, I say simple, it's actually a cart which can drive around and be programmed, okay? So this is a lot like a lot of the robotics we're doing in schools. If you're doing Lego, the first Lego League, this is very similar, but this is used in industry today. So maybe you want to be on the Robot Ranger team. Okay. What else can we do? Well, here's another type of robot, and this clever design is a bit like an inchworm. If you've ever heard of an inchworm, the idea is it can move around and it's very articulated. It's got lots of moving parts that can move around to inspect places. Okay, so it's a bit like an inchworm, sort of goes like inches along. Okay, it's called an inchworm because as it moves along, it moves about an inch. And an inch is about 2.5 centimeters. Okay, it can move along. So this robot is very much like that. It can inch along, it can move along, and it could then be inspecting maybe places we don't want to go or can't go easily. Yeah. So maybe you want this morning to be on the Robot Rangers team. But what about Nature Protector? Okay. We talked about there how we could not just try and reduce energy, use renewable energy, but also then think about how we could maybe capture carbon. Or even as that's happening, and all these different things, as we're hungry for energy, as Dallas said, we need lots of energy for AI, we need lots of energy to do lots of things. We need to look after our environment as well, making sure we don't destroy it, or make sure it's looked after carefully. Okay, so maybe you're thinking about how you might use drones to do that. So we can use drones to fly over the forests, go places where we can't go easily, and then you can also try and see what's happening. So these drones can go and see maybe where there's deforestation, where the trees are being removed, and is that being done carefully? Is it actually looking carefully about what they can do to keep things safe and look after the environment? Okay, and these drones can travel huge distances, places where we can't get to easily. Okay, think about in South America, we've got the huge rainforests. It takes a long time to get to the middle of those rainforests. So drones can fly in, fly over, and can see what's going on. Okay. They can also spot things like this. So this is where a drone is actually looking for a rhino. I'm not sure if you can see there in the middle of your picture. It's quite well camouflaged. There's a rhinoceros there in the middle of that. So you can use things like drones to go and check on nature that the animals and the other creatures in those forests aren't being affected. Okay, and this is actually an example where they're looking for poachers, where people are poaching the animals. So it's going to protect those animals and using technology in that way. Also, under the sea, maybe you want to help protect under our sea. So under the sea, we have our coral reefs, and the coral needs looking after. And therefore, we could send like an underwater drone to go and look after them. But also, look at this one. Looks more like a human, doesn't it? And this one's not only just going underwater to go and check on the plants and see if they're okay, it can actually tend and look after them. Okay. So if you imagine if you had a garden, maybe you got a garden at school, you might want to go and look after it. You want to go and plant some plants. You want to make sure that the plants have all the nutrients and things they need. And also you'll tend them and make sure they're looking after each other, looking after things well. So here we have in my room, I've got a lovely plant here, which looks nice and healthy. And oh dear, look. This one doesn't look very happy. So maybe I need to tend and look after my own plants here. Okay. So we can think about how we can look after the environment, how we can look after nature and do that. And our final example this morning is the data detective. Okay. So I'm mentioning 4 different roles this morning, but you can think of other roles that could be involved in your team as we do this. Okay. So when we think about data, we think, well, we do that in maths. Maybe we might do some charts, we do some pie charts, we might be doing some histograms, some different types of bar charts and things. And we need to collect that data. And sometimes it can be easy. You can just write it down. You might do a little tally chart and see how you go. But we could also use our robotics to do that. So for example, this is a tiny robot which can go inside pipes and check that pipes are okay. Okay. And again, it might be somewhere where it's somewhere you don't want to send a human because it's not safe, or maybe you can't send a human there because it's too inaccessible, it's too small. Okay. So thinking about that, you might have robots can go and collect that data in the go and do that. Okay. Okay. And Dawn's mentioned there, if you've got any questions as we go, because we're going to get active in a moment, but if you've got any questions, then you can put those in the chat and I'll keep an eye on the chat too. Okay. So yes, do add questions in the chat if you want to, or have somebody in your class can help you with the chat. And I'm hoping by now we've had enough time for our schools to arrive. I know it's first thing in the morning, but also what I'm going to say is get ready with your piece of paper. You're going to need that in just a moment. So make sure you've got a piece of paper each. You're going to need that for our activity. So we were talking about robots going into tunnels. And here we have some robots which can actually sort. So when you put your recycling out, where does it go? You know, it goes off in maybe a bin, goes somewhere else. Maybe your school has big recycle bins, things like cardboard, plastic bottles, all these sorts of things. And we can use robotics to sort that. Okay. And not only can we use robotics to sort it, to try and make it better to recycle things, not only can those robots be made more efficient, but we said we can capture the data, and that data, that information, we can use to try and make it better, to save energy, to make it go faster, to make it more efficient, to try and help our planet. And maybe also we can use it to try and think about which energy sources we're using. So here's an example then about how we're going to use that. How do we use AI? Okay. Now we hear AI mentioned a lot. We hear it a lot in schools. We hear it a lot on the news and everywhere. People are saying, oh, we've got to use AI. Maybe you've used some tools to change a photograph or to create some images too. Maybe you've used ChatGPT for your homework. Yeah. Is it a bad thing or a good thing? You see, you can use it to gather ideas and sort of get yourselves thinking. But AI, or maybe we're going to think about this morning, how that computer learns, how the computers learn together, needs a lot of energy too. So that's going to think about that for net zero. So we're going to think about how you learn. And we're going to do this by doing an activity this morning where you're going to make a shirt for our team. So here's a paper shirt. It looks like the Argentina strip. So this is an activity you can use to make football strips. But we're going to do this one for our net zero team this morning. Okay. So hopefully what we're going to do is you're going to get your piece of paper. I'm going to show you how to fold it. You're going to follow those instructions. We're going to see how you learn. And then we're going to see if that's how we can teach a computer and see how a computer can learn. Okay. So you're going to need your piece of paper. We're going to fold it. And then after I finish this morning, you can then decorate your shirt or make some more of them, or think about, what it would be you're going to put on your shirt. Are you going to be part of the Solar Genius team, the Robot Rangers, or the data detectives, or are you going to be a nature protector, or maybe even something else you can think of? So hopefully you're ready now with your piece of paper, if you have your piece of paper. And hopefully you can see this screen large enough that you can follow along as we go. Okay. So here's your piece of paper. You want to put it flat in front of you. I'm going to describe the instructions as we go. And here we go. We've got a piece of paper, which we put landscape. Okay. And we're going to start by folding it in half. And I could describe that as along the long side of the A4 piece of paper. So fold that in half. I'm trying to get the corners together to be as accurate as I can. Okay, and then I can open that out, and you can see I've got a crease down the long length of the A4 paper. I'm now going to take that side again and fold it into the middle, up to where the crease was. Okay, so I'm folding that up to the crease. Trying to make those as accurate as possible. Okay, I'm going to turn it around 180 degrees, and I'm going to repeat that action. I'm going to fold that into the middle. Okay, so we've got like a mirror. We've done that there to make those two doors on our piece of paper. We've mirrored that action and turn it around 90 degrees. Okay, and if you're stuck or you want to check it, you can always check with your neighbor. Okay, now I've turned it over. So look, I've turned it over, and now I'm looking at the back of it, so it's not the side which has got the open sides, and I've turned it over to make a bit like a square shape at the top, so around a sort of rectangle square. And as you try this out, you might want to experiment with different sizes of that fold. Okay, so it's probably about, you can see it's about the size of my thumb, probably a bit smaller than that. And then I've turned it over again. Did you see that step? I've turned it over, I've folded it back, I've turned it over again. So this is going to form the collar of our team shirt. So if you think about football strip, for example, the Lionesses football strip has got a collar on it there. We can do it like that. Okay. So I've made the collar part of my shirt. Coming down to the other end, I'm now going to fold this out. So it probably folds about, shall we say, below halfway up. It's definitely below halfway up there. Okay. We're not measuring this, are we? We could measure it. Maybe that's something you want to do to make it more accurate as we go. Can you see I've folded out those two sides? So does it look like a rocket? There we go. And then we're going to fold this up, and those bits I fold out are going to make the sleeves. And I'm going to tuck this underneath the collar. Underneath the collar, like that. All right. So can you see how it makes the collar? This bit tucks underneath, and then you got your sleeves. Okay. And that is our shirt. Okay. So I'll pause there for a moment just to let you to finish, or if you want to check with your friends how you're getting on. If you have finished it, then maybe what you want to do is to compare it with your neighbour. Yeah. Have a look at the one that somebody else has made, and how does it look? Okay. How does it look? Right. Okay, team, are we okay? So we've been folding our team shirts. Now, when you've got all those together, if you look around and look at each other's shirts that you've made, you'll notice that they may be slightly different, okay? So even though I gave you some instructions, they've turned out differently, okay? Why would they turn out differently? Well, maybe because as you've been folding them, you've maybe folded different distances. Maybe some of you have done really precise folding towards the corner, okay? And when you folded it, you got some nice accurate 90-degree corners in there, okay? Maybe you did a different size of the collar, and therefore it's turned out differently, okay? So depending how you want to do it, what you could say is, you could say, well, I know this is, when you look at the more, you say, well, I think that's a really good example of the shirt because I think I like the proportions of the collar, I like the proportions of the body and the sleeves. Or maybe I really like that one because that's got really accurate corners, really well, each fold is really precise. And maybe you got another one which didn't go as well in your first attempt. Maybe it didn't quite match up, or maybe you're not happy with how some of the sizes of the collar and sizes of the arms and things, and you want to have another go. Okay, so after today you can go and have another try and make those. And if you can't follow this, we're trying to share these resources, but you can also look online how to make an origami football shirt. Okay, so when you've made it, what you might do is then get all of them together, okay, and look at them and judge how well have you actually put those things together. And what you could say, for example, is there, well, I think this one's a good example. We'll use that one as a good example. This one didn't go quite so well. We'll not use that one. So as humans, you might choose which one it is. Also, as humans, if I said to you now, you're going to go off and you're going to make 100 football shirts, okay, you'll probably get better each time you do them, or maybe you'll get faster or more efficient, okay, as you do that. And this is what we want to think about for how we're going to train our models, okay? So if I think about that, if we're going to train our model, okay, let's start with an example, okay, of how we might do it, okay? Okay, so after our lesson today, what you might want to do is go and write down the instructions. So for example, trying to think of the steps that you use. This is like us learning. But what about our computers, our machines, okay? So I'm going to give you an example this morning of how a machine learning model works with faces, okay? And I'm going to use Scratch this morning. So hopefully you've used Scratch already. Maybe you've used it in your computing lessons. And Scratch is a great resource, and it's a great resource for putting those blocks of code together and seeing what happens, okay? So what we do is we try and put those blocks of code together, but there's a brand new block called face sensing, okay? So I'm going to show you that this morning, okay? Welcome all schools. Thanks for those wonderful shout outs. Good morning to Corstorphine. Good morning to Houghton the Spring. All these different places coming in this morning. Great to see you. So let me show you now. If I go here, and we're going to get the Scratch open. So Scratch open. So if I come out of here and I come into my Scratch environment, this is Scratch as you've seen it. When you go into Scratch, you know that you can go and create a model. So I'll go to create. And I've got all my different blocks here, as you'd expect. But down here on the left, now, if you go into this purple area down at the bottom, okay, there's a new one called face sensing, okay, so face sensing. And if you tap on that block, what it does is it adds some new ones, some new instructions for us to use. So if I go to face sensing like that, I tap on that, and over here on the left, what you'll find is, oh, here I am. Over here on the left, you can see there's some new ones called face sensing blocks, okay? And let me just show you what they're like. So for example, there's a block called go to nose. So I'll drag that on the screen. Let me make that a bit bigger so we can see it. Go to nose. So here's our Scratch cat on the screen. And whenever I tap on this block, can you guess what it's going to do? Yeah, it's going to go to my nose. So look, if I put my nose over here and say go to nose, whoop, it's gone there. If I put my nose over here, there it goes. So it's using this. I'm going to just go a bit bigger. Okay. It's using this to try and work out, you know, where my nose is on my face, and it moves the cat to that position. Okay. So let me just go back to the code and let's add some code to it. So what I could do is, and you're familiar with these things, there's my start. Let's go and get a loop and say forever go to my nose. Okay, so off we go. Let's make this bigger and start it. Okay, and it's forever going to my nose. Look at that. So how is this model working? Okay, so this model is working because it has been trained. Okay, it's been trained like you've just made your model shirts. It's been trained to do this. Okay, so it's been trained to look for faces. Okay, so for example, you as humans, you might say, well, you know, what's a face look like? It might look like mine. What if I had something like this? So this is like just a yellow circle with some googly eyes on. Will it recognize it? Let's have a look, shall we? So if I come back to our screen here, I'll go off the screen here. Will it recognize this face? Oh, can you see? So it's looking for something which is round and maybe something which looks a bit like eyes. Okay, so it said, look at that. So I've said use that. All right. So, and here I am back. So it recognizes me better, but something like that, you know, on its own might just say, not trying to trick it. But what we're saying is that is how it's been trained. It's been shown a lot of faces, and on all those faces, it said that's where the nose is. And then when you run that block, go to those. Okay. So let's go back to our code. Okay. So here we are on our coding. So there we said go to nose, but we can go to other places. Say go to mouth. Okay. There it is with my mouth. Or we could say go to top of head, and you can go to the top of the head. So again, maybe you've played some games like this where we can have you know, the name of a particular, you know, famous person, which is on your head, and you have to try and guess the name of that person. That sort of idea. That's how those games work. But this model here in Scratch has been trained on us using machine learning. So it's been shown lots of examples and trained to use that. So the good thing about this example with Scratch is it's not storing the data on the computer, but it's actually using, you know, it's been that training that machine learning is doing it. So what else can we do with it? Well, then you can start to play around with it. Things like, for example, you can have this where we can have, okay, actually I'm a bit bigger. Let me just refresh that. Okay, loading my project and making it bigger. Here we go. And when I say play, oh, you can see there's some googly eyes and a hat. So I've got a block saying find the top of my head and put this on here. Find where my left eye and my right eye are and put those on the screen like that. Okay. So you can go and try this out. So after this morning, you can, after we've had our fun day together, you can go off and find Scratch and find face sensing. What else could we do? Well, here's another one. Here's a game. So when you search on Scratch for new examples, okay, we can try and do this. That's our googly eyes one. Let me go and find another game for us. Okay, so what we can do is we can say, well, you know, how is this relevant to what we're doing, right? How is this relevant? Well, the idea is we're thinking about machine learning and how it can be used to do different things. Okay, so here's a lovely game. Eat the donuts. So maybe this is something you could use. You could think about maybe getting a net zero game as part of your team, using that face sensing, but that's been machine learning has helped us do that. And machine learning is part of our AI. So how exciting. You can go and try out different things and try out using that machine learning, how it's been trained to do things. Okay, so that's face sensing in Scratch. We can go and try that out. And then also you can try out different things. But what about data collection? How can you go and gather that data? So my second example here is where I'm going to show you about using the microbit. Okay, so again in schools, we've got these microbits were distributed a while ago, but also often we find them used in your schools. Maybe if you're using them in the lessons, great stuff. You can go and find those today. But if they're not, maybe ask around and have a look around. There were lots of microbits distributed to schools in the past. So it's something we can use. And again, here's a new example of a way we can use this tool. We're going to use a tool where we're going to train the model so that we can capture some data to think about it. So this morning, we're going to use the example of maybe we've got some tidal energy. Okay, so we want to gather the data about how much the waves are moving up and down, for how much energy we could gather. So if you think about the sea, sometimes we've got where it's like, no, just little waves, little waves, little waves. And sometimes we've got big waves. Okay, so with me together in your classroom now, do you want to try that out? Would like to say still. Little waves, little waves, little waves, big waves, big waves. Try it out. Let's see the energy in your classroom. Little waves, big waves, and still. Okay, because we're going to use that now, that idea to train our model. Let's have a look. Okay, so we're going to use a tool called Microbit and then Create AI. So again, for your teachers, you can go and say that you're going to write this down, Microbit and Create AI. Okay, and what it does is it uses the Microbit tool to gather some data and try and recognize that data based on how we've trained it. All right, so let's give this a shot. Okay, so let me show you live. So if I come here and I get my web page, which is called Create AI. It's not this one because we're going to go across to this one. There we go. Microbit Create AI. All right. And what we're going to use is we're going to use this tool to gather some data. All right. So this morning, here I am with my Microbit. Here's my Microbit plugged in. Okay, you can see that. And again, this is what the box looked like. Maybe you've seen it around school. If you're not using them already, please do go and look them up. Okay, so there's our Microbit in there, and you can see I've got a lovely smiley face on it at the moment. All right, And what I'm going to do is I'm going to take you through the steps just to quickly train our model. So we're going to need you to help me out with the still, little waves, little waves, little waves, big waves, big waves. Okay, so are you ready? Let's get going. So here we go. So here is our data. And I've got my microbit set up. What it'll do is on the website, it shows you how to connect it. So what we're going to do here is I'm going to say I would like this action to be big waves. Okay, so big waves. Right, there we go. Can you see that? Big waves. So I've typed in big waves, and then it says, can you record that? Okay, so we're recording at least 3 samples. All right. And down the bottom of my screen, down here, it's actually checking to see what movement is happening with the model. So let me zoom in over here. Okay, if I was to move my microbit, okay, and move it around, can you see how it's moving around like that? Okay, let me show you that again. So here's my microbit moving around like this, and here it is on our screen. Look, there it is moving around. You can see the data coming in there. The data is happening. Okay, so let's try to train our model. So if I press record, it says it would like big waves. So you ready? 3, 2, 1. Big waves, big waves, big waves. Okay, that was 1. Let's try again. Record. Big waves, big waves, big waves. Like that. And finally, record. Big waves, big waves, big waves. So I've got recording for 3 big waves. Okay, now I'm going to add small waves. So small waves. Okay, so there we go. Small waves. I'm going to record again. So are you ready with me to do some small waves? Ready? Small waves. Oops. Let's try again. Record. Oh dear, I've lost my connection. It's always the danger of the live demo, isn't it? Let me just try and reconnect. Okay, so what it is you can record your data and you can try it out. Okay, try and get it to work. And I might just have to go back to an earlier one if it's not going to work for me here. But what you got is you can train your model. Here we go. We can quickly reconnect, and then we can do it. There we go. Wonderful, wonderful, wonderful. The fun of the live demo. Okay, so what we're trying to do there is we're trying to get the data collected using the model, collecting things. I think I was a bit too exuberant with my big waves, and I managed to disconnect it and pull it out, unfortunately. Let's try again. Oh, I can see why. My power's come out of it. Oh, silly me. I can fix it. We can do it. Maybe I can't. But what I'll do is I shall move on, but I shall help us do that. So I'll just see if that comes back to life. Go on there, microbit. So we're going to connect it up and see if we can do it there. This is the song you make when you're doing connections. Okay. Bum, 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 bum. Okay. It might just be classic. It's not going to work this morning. Oh, we're back. We're back. We're back. Here we go. Are we ready for your small waves? I won't be do too many small waves. Ready? Record. Small waves. Small waves. Small waves. So you can do this in the classroom. Small waves. And finally, small waves. Small waves. Okay. And there we go. And then finally, we're going to do still. So we're going to do it's nice and still. So you're ready to be still? Ready to be nice and still and calm? Okay, we'll do that. And ready, record. Right, so we're not moving. Nice and still. And again, nice and still. And finally, nice and still. So here we go. There we go. So we've got our things. So we've got the nice and still. And now we can train our model. So here it is. We're going to train the model like you trained yourself with the making of the football strips. Okay, for the team strips. Okay, it's training the model. So what it does is it takes that data, it recognizes that's what a big wave looks like, that's what a small wave looks like, that's what a still wave looks like, and then we can test it out. So let's see, here's our model again now. if I move it, okay, so I move it a little bit, it says that was a small wave. Okay, that was a small wave. And if I try it now with a big wave, big wave, big wave. Okay, it's showing it's a big wave. It's recognizing it. It's telling us how accurate it thinks it is. And if I leave it still, if you can see here, it's recognizing it as it's being still. All right. And then if you want, you can go on to use Scratch again. So we use Scratch. You could go to use Scratch again to make some blocks and to test it out. So we are data detectives. We're data collection. We're collecting that data to help us out. Okay, so this morning we've been thinking about our teams. We've been thinking about how we might join together as a team. And we're thinking about how we might have our different roles in the team, okay? And data detectives can help us by fighting climate change, by cutting costs, making things more efficient, like that sorting of the recycling. It can maybe make renewable energy more faster and maybe increase efficiency. All right. So it's all about teamwork today, team. We're going to work together to try and reduce it, to try and get to net zero. And my final example here has just been announced last month. You've heard of Google. Well, they're saying, well, we maybe could do a way of putting together our different roles of robots and AI and nature and also data in this new project they're considering, where they're going to essentially put computers up in space to do all the AI processing. Okay. So for example, all of that computing takes a lot of energy, a bit like if you're moving around a lot for those big waves, it uses your energy. A lot of the machine learning and AI uses lots of energy. And we're going to learn about today about hydrogen and other tools and other ways we can generate that energy maybe more efficiently to help with that. And I even heard a story that in London, they were having to stop building houses because they knew there wasn't enough electricity for those houses and the new big data centers which were needed for all of the computing. So Google's got an idea called Google Suncatcher, where it's going to put into space as satellites, many satellites, which can capture the sun, hence the name Suncatcher, using solar panels. It can then do that processing, that machine learning and sorting of all that AI. It can maybe be more better for the environment because it's not taking up fields, or maybe it's not needing space on Earth where we could be growing other things. And maybe using that data to see how well we can use that data to make things more efficient. So it's a new project just announced. Maybe that's something you can think about, which your team might want to help with. As we head towards net zero, using your robotics, your AI, and your data collection. Okay. So today we've talked about our solar genius, our robot ranger, nature protector, and data detective. You can think about which one you might want to join, but they are all joined together. They all do work together as a team. Okay, so thank you for this morning. Thanks for all the wonderful things we've been doing. Hopefully you're not so out of breath from doing the big waves and the small waves and the little waves. You can go and decorate your team shirt. Later on today, you can go and colour it in, decide which team you're part of. And then also you can think about how we can work together. So for example, today we've been working together with RTC North and myself here with the Royal Grammar School Partnerships. We work with schools across the Northeast, doing lots of different projects with robotics. So thank you all very much. Thank you.
Steve, amazing. What a lesson. I'm still trying to train I started doing your shirt and I ended up making a small bird with wings that sort of flap. I thought that was a
Fantastic.
very, very interesting lesson. Actually, I do a little bit of work in the space industry, and your idea of solar panels in space, it sounds like one of those science fiction ideas that people have dreamt about, which will never happen. But it's actually happening. It's a really, really big and important idea. Because early on in your talk, when you had the little robots cleaning the solar panels here on Earth because they get dust on them, of course, out there in space where the sun is always shining, there's no dirt to cover those panels, so they'll be much more effective. In fact, I think we should go a stage further. I think we need to move all of heavy industry off the Earth and have it in space where there's a lot more room, and then we can concentrate on a much cleaner planet. We've got loads of questions. Actually, funnily enough, you know, when you were talking about training your model, one of the reasons I did a little bird here is because the Japanese Space Agency, when they're training astronauts to actually go up into space, they get them to make hundreds and hundreds of paper foldable cranes, and they look at the accuracy of how well they make it, and they can tell what the astronaut candidate is thinking, if they're stressed, if they're concerned, just by looking at the accuracy of their folds. So there you go.
Wow.
You can learn all kinds of things from origami. We've got some questions, some great questions. Let's start with, there's some quite difficult questions, Steve. Let's start with Mrs. Whitfield. Do you think robots will ever entirely replace humans?
Well, that's a great question. It is a great question because there's so many good things about us working together with robots to do things together. I was learning the other day about people who had, for example, a medical problem called a stroke, where they need to recover their body, and they can have human interaction to try and help them, recover from that. But then maybe it doesn't last long enough, and that's where robots can be helpers and continue to help us recover and be beneficial. So in some ways, when I think, will they replace us? In some ways, I always hope we'll still be around, but I think I'd rather think about it as there's many benefits of us working together in that sense, rather than it's being a threat to us. I think they're there to help us, and that's how we should really be thinking carefully. But also, as we've been thinking about this morning, how we're training those robots and training those models, we need to be careful that we are doing it in an unbiased way, making sure it's all fair and equitable as well, so that when they are trained, they will be there to help us and not dominate us and take over the world.
Exactly. It's quite a fun thing as a human to imagine terrible scenarios. The human imagination takes us into all kinds of extraordinary and exciting places, which can be fun. But robots they've always captured our imaginations, haven't they? I think about science fiction films and stories. Robots always play an interesting part. Oh, Meryl, who's coming on next, saying that's a hard act to follow, Steve.
Oh,
I have a question for you, which I wonder if you can help us with. And you sort of touched it at the beginning. We talk about this idea of net zero, about how we can sort of reduce greenhouse gases, but what does the net in net zero mean? Like, zero means nothing, I understand that. But what does net mean?
Gotcha. So I think when I first came across the word net, you talk about it in terms of if you're putting some money into the bank, and you used to think about, you get some interest back from the bank, and they say the net amount would be like this, the sort of smallest amount, and the gross amount could be possibly the best out of that. So I often think of it like a bit like that. So it's like the net zero is basically that we're on a balance. We're doing, shall we say, okay, we're sort of about the minimum we'd like to be.
Yes,
but we could have a gross, we could have a much better effect.
So that balance is a little bit like, it's not about burning no energy, but it's about, if we do burn some energy, then we have to balance that out by reducing how much of that goes into the atmosphere. So you get this sort of, balance, exactly, like a sort of seesaw.
Yeah.
Okay.
Yeah.
That's good to know. It's one of those terms.
You see some companies make planting trees for carbon capture to try and balance out when you're maybe increasing the size of your plant, where you're growing your robotics plant and building more robots. Maybe plant more trees to try and capture that, or something else like that.
I was never going to be an accountant growing up. It was gross and net. I'm lost. We've got time for one more very, very quick question before Meryl comes on. And actually, this is a good question. Very quickly, in your opinion, Steve, what do you think a simple thing that primary school people can do to make a difference to that balance? What would you suggest?
Gotcha. I think, we're doing it today in some ways by being better educated. Is a great way of us learning about it. Yeah. One thing I'm currently interested in, and again, schools can get in touch if interested too, is mushrooms. We know that we've got mushrooms around, and we eat mushrooms, and people either like mushrooms or don't like mushrooms. There's probably no in between. But their roots, the roots which have the network, the mycelium in the roots there. That's a great way of not only helping plants to grow, but it's a way of capturing carbon as well. So maybe that's something schools want to investigate. How can maybe something like that help with if they've got a plot outside of they're growing plants already at the school or an allotment or something like that? Is that something they could investigate?
Really good idea. I actually think just getting outside is such a good idea. getting outside and being aware of nature, looking at birds, looking at how things grow, all that kind of stuff. Funnily enough, your mushrooms, many years ago, I did a program called Britain Beneath Your Feet for BBC One. And I did a whole program all about mushrooms and tree roots.
Yeah, yeah.
Maybe it's on YouTube. Who knows?
I shall look it up.
You are a genius, Steve. I thoroughly enjoyed your lesson. I apologize for going slightly rogue with your origami, but it was terrific. I want to be all of your characters. I want to be the data detective. I want to be kind of a bit of everyone. I thought it was really good.
Yes.
Anyway, thank you very much indeed. We will see you soon. Thank you for answering your questions.
Right. Thank you all.
A great pleasure. Right, who we got next? That was Steve Bunce. Thank you from the Royal Grammar School. We've got Meryl next. Where's Meryl? Is Meryl here?
I am. Hello.
Awesome. Meryl Batchelder, if I pronounced your name correctly.
Meryl Batchelder will do just fine.
Okay, perfect. Dr. Meryl Batchelder, I should say.
Indeed. A long time ago, I did a PhD and then went into education at the ripe old age of 40
Wow.
and haven't looked back. Absolutely adore working with kids.
Yeah, me too. Now, listen, there's a word that you're going to be talking about in your talk, which I love, which is this thing called biomimicry. Bio kind of means biology, I'm guessing, like living things.
Organisms.
By mimicry, like mimicking, copying.
Yeah, we're gonna
copying biology.
Yeah, we're going to be copying biology to think about solutions to some of the challenges we face.
Can I show you what I found in my garden today, this morning?
Go ahead.
So I have a big hedge in my garden, which of course it's winter, so all the sort of leaves have gone, and I found this. It's a beautiful bird's nest. Which of course is empty, so I'm just, in case you're wondering, there's no birds in it, so it's an abandoned nest. But I'm thinking how beautifully constructed it is, how beautifully designed it is. It's almost like design, and this is just in my.
And it inspired a stadium for, I think it was the Beijing Olympics. There's a huge stadium that was called the Bird's Nest because they used that. Yeah, so they used that as an inspiration for their building.
My friend Steve built it, who's an architect, and I should have got him on. We could have a whole conversation about the bird's nest.
We could have just talked about that one. Use. We're going to be trying to get all of the young people listening today talking about and thinking about how we can use nature to inspire them.
Great. Well, listen, I'm gonna shut up and let you crack on.
I'll try and
all the teachers, kids watching Meryl talk. If you get your questions in the chat bot, chat doodah. If we've got some time afterwards, then we can put them to Meryl. Okay, over to you.
Okay, right. Let me try and get to my screen. Oops, where's it? There we go. Hold on. That is that now sharing? I hope so.
Yes, it is. I think it is.
Okay, so we can see that. Lovely.
I can see that. Well, I can see lots of all the names of the people.
Can we see? Oh, can we see that one? Can we see the bird?
No.
No, we can't see the bird. Right, okay, let me try that again.
We've got a crack team of
no, that's fine. That's fine. It was
Microsoft
me.
whisperers on.
It was me for sharing the wrong thing. So let me stop sharing that one. Stop sharing. Right, okay, let me try that again.
Okay.
I do have my presentation ready to go. Let's try this way. There we go. Let's try that one.
Got it.
Okay, right, fantastic. So let's do that, and then I am ready to go. So today we are looking to see if nature can inspire technology, and I've got a beautiful kingfisher there. So my name's Meryl. I work for a company called Terraligo, but also for the Ministry of Eco-Education. I have an icebreaker for you. Hopefully you've got something to write on, a whiteboard, a piece of paper, but you don't need to write quite yet. So the first thing is think of your favorite animal and one cool thing it can do. And so I'm going to give you a minute to do that. So you're going to think about it, and then you're going to share with your shoulder partner. And there should be a little countdown clock in the corner of your screen. So think about your favorite animal and one cool thing it can do. And then you're going to share with your shoulder partner and explain why you think it's so amazing. So I'm going to let it count down. So you've got 20 seconds left just about. Now, definitely should be starting to share what your favorite animal is with your shoulder partner and why. Why is it so amazing? Ten seconds to go. Okay, and stop talking. So this is my favorite animal. Mine is a polar bear, definitely one of them. And the reason I love it so much is because it's beautiful and lives somewhere incredible. But the way it's adapted to survive in its environment it's by its fur, really. They've got three key adaptations to keep them warm: a really thick layer of fat, which is insulating, black skin underneath that white fur that absorbs the infrared rays from the sun, and this dense undercoat of fur with hollow shafts, so it's like hollow hairs that reflect the light. And it's that last feature that has helped scientific researchers think of a cutting edge material for exploration of space, going back to AI and Google in space. And the polar bears are unique that their hair is hollow. And what it's done is each fibre has evolved to optimise heat retention, to keep it warm, and water resistance. And it's inspired some ultra lightweight materials known as aerogels that are used in space exploration. So one simple thing like a polar bear can inspire a whole different area of technology. And engineers are often hit with problems. The Japanese bullet trains, the Shinkansen, were super fast, but made a huge boom when exiting tunnels. And it was really upsetting for the people who lived nearby. They couldn't get to sleep. So engineers thought about how they could redesign the front of these trains, and they looked at the kingfisher, which dives into water really fast with hardly making a splash, no ripples as the bird goes into the water. So the engineers copied the shape of the kingfisher's beak to redesign the train, and it made it faster, used less electricity, and was much quieter. It's now infamous around the world as one of the best railway systems anywhere. So some real inspiration from a live animal to help us with technology. And there's loads, absolutely loads. Once you start looking around in nature and thinking about world's problems, you'll become experts soon. So before we get there, which other animals are really good at moving through air, and that's called aerodynamic, or water, hydrodynamic? Jot notes if you have a whiteboard or pen or paper, or just think of some and maybe name them out to your teacher. If teachers have got any suggestions, you can put them in the chat. And I'm going to start my timer. You've got 1 minute. "30 seconds. How many animals can you think of that are aerodynamic or hydrodynamic? Three seconds, 2, 1, and stop talking, stop writing. What did you think about? Oh my goodness, there's animals, and animals are really amazing, and they can move through water, move through air really, really fast. So I've come up with some suggestions, and they are a peregrine falcon, a bottlenose dolphin, a tuna, an orca whale, and down here we have a gannet. And some of them can even move through air. This dolphin's moving through air and water, and so's the gannet. So their streamlined shape makes them move really fast through either air or water. And we can use that to really help us think about how things move and how they're aerodynamic or hydrodynamic, and how the particles of the water or particles of the air run over their body. And nature has been designing and testing solutions on Earth for a billion years. Okay, so natural designs are tested by evolution, and only the best survive. We know that. We know that things die out, but other things are developing and adapting and evolving all of the time. Even humans are evolving. One of the most important things that evolved on Earth was plants. I have my pet plant here. It's called a monster plant, and that green color is because plants can photosynthesize, and they have something called chlorophyll in their cells, and they can literally take sunlight from the sun and convert it into food through a process called photosynthesis. Absolutely amazing thing that they can do. We humans wouldn't be here if it wasn't for plants adapting to be able to create their own food. And it's why when you look at Earth from space, we've got those beautiful green areas, which are forests and grasslands, so that you can see that Earth is a blue-green dot. The Earth in the green is from photosynthesis. So what I'm going to ask you is, so plants developed and photosynthesize and grow, but what happens to an animal or plant in nature when it dies? Because nature is really unusual. So I'm going to give you 2 minutes, and I want you to think about what happens when a plant dies. Share it. Think about all of it. What happens, it's not just dead and falls to the ground. Think about what else happens. Okay, you've got 2 minutes. What happens to a plant or animal in nature when it dies? So think first. Now you've thought of something, now share it with just your shoulder partner, just quietly. Make sure you listen to each other. Okay, I'm going to give you about a minute on each table to share your ideas. Try and think exactly what happens. A leaf has fallen off a tree. What happens to that leaf? Hopefully no leaves will fall off my monster plant. A bit protective of it. Sorry. I've just lost my timer. Never going to let me back on again. I'll give you another 30 seconds. Let's start playing this. So you've got 30 seconds. Playing with my mouse. So 15 seconds to go. What happens? Are you going to be able to explain it? Okay, and stop sharing. So hopefully you've thought about that leaf falls to the ground, and what happens is it'll reach the soil, and then it'll start to break down over time, and you'll have new microorganisms break down the leaf in the soil, and earthworms are incredible. And they'll start this recycling along with that mycelium from the fungi that are underneath the tree roots. And dead trees become homes for beetles and birds and fungi and moss, and they break down and they release the waste leaf materials, nutrients back into the soil. It's recycled. And we can think about that for anything from nature. If an animal dies, its bones will slowly get dissolved, releasing calcium into the soil. And nature is amazing. It creates no waste. Waste, all that rubbish that we produce, all that litter on the floor that we have to try and pick up because people have dropped things, that's a really human thing. Nature doesn't create waste, and it uses really, really low amounts of energy, like that photosynthesis, taking energy from the sun. And so what we need to try and think, and it's called a circular economy. Nature has the perfect circular economy. Nothing grown by natural organisms, living organisms, is wasted, except by the humans. So what we need to do is try and mimic that circular economy. So we've got to think about those raw materials coming into this system. We've got to design solutions and reduction and distribute things and reuse things and reduce how much we use and collect anything in that we cannot reuse and recycle it. We want to minimize any waste. Literally nothing from the kitchen, nothing from anything we buy that we don't want anymore. We have to try and reduce it because the waste is causing us real problems, and it's a waste of energy as well as materials. And so what we're going to try and think about is this net zero circular economy. How can we design things that help us reduce waste energy and materials? And basing designs on nature is called biomimicry. As Dallas and I were talking about earlier, bio relates to the living organisms and mimicry means to imitate or copy. So we're trying to get this to be circular. So I've got a few things here. We've got some animals, and we're going to match the adaptation to the technology solution that people have used to try and make things better. We've got 4 different pictures, and we've got artificial tendons for surgery, and parachute cords is one thing that's been created from one of these animals. Wind turbine blades that generate 20% more electricity. Super strong adhesive tape that works in space and surgical bandages that stick to wet skin, and a cooling system for buildings without electricity. I'm going to give you 2 minutes. You can discuss on your tables what matches with what. What are they? What are the animals? And what's the adaptation to the technology solution? So how are they adapted? So you've got just less than 2 minutes. Now, I was trying to see the chat, but I can't see the chat for some reason. Oh, look at this. We've got loads of suggestions. That's why I wanted to see the chat. I don't know if I can.
We've got loads of suggestions for your.
Okay, right. Okay. So yours. That's fine. You're seeing those. Fantastic.
Yes, we are. If you've got any questions, anyone for Meryl, get them in, and I can.
If you relay them, Dallas.
Yeah.
I would be massively grateful for whatever reason. Teams is my nemesis. I don't.
Me too.
So I can see my screen and I know what I'm doing. I can see my timer, but I don't want to mess with the timer and look at the chat. So if you can just tell me. But I saw there was loads. Okay. That's amazing. Yeah. People are entering.
Megan Naylor, she says sticky tape must be gecko feet.
Well, that's a really good guess. And look at them. They look really, and they look. It's a gecko. You've identified it's a gecko. Well done. Got less than a minute now. Have we identified all the other animals, Dallas?
Oh, well, Megan's on fire now. She says wind turbine blades equals whale fins.
Oh, she's good.
BKJ Towers says spider web equals parachute cord.
I think that's a great guess.
Well, we know that spider silk is incredibly strong, don't we? Mr. D. Smith, bottom left is termites for cooling systems. That's interesting. I'd like to know if that's correct and how that would work.
Okay.
Someone else, Mrs. McKinnell. Hi, Mrs. McKinnell. She says whales equals wind turbines. Megan says tendons equals spider silk. So that's a good one. Yeah. So lots of very, very sensible
suggestions. Lots of discussion going on in those classrooms.
Yeah.
Got 5 seconds left, and then I'll tell you the answers.
I'm trying to work it out myself as well. I think.
Thank you, Dallas. You're a superstar. Right. So let's have a look. So the gecko, it was a gecko, and it's for tapes and bandages, and actually can be used in even used in space. But that super strong adhesive tape can be used on wet skin, all sorts. So really amazing. But we've taken that inspiration from those little gecko feet. Spiders, absolutely. Tendons and cords and parachute cords, really, really strong. 5 times stronger than steel, but it's stretchy and lightweight. So I must admit, I've got a little bit of arachnophobia. Even just looking at that spider makes me a bit scared, which is totally irrational because there's no spiders in the UK that could harm me at all. I don't know what it is about them, but we can use their adaptations to surviving in nature to help us. So I love them a little bit more, but I don't know why I don't like them. The whales, absolutely, those tubercles on the whales, the shape of the whale's fin there, can be used to help cut through air, their particles in air, so that it can make it more aerodynamic and more efficient. And finally, we have termites, and those little holes that they're making, those little tunnels that they're making in their mounds. We've created buildings. There's a building in Zimbabwe which uses this cool air coming in and helps the warm air, because we know warm air rises, and that's the method. And these termites have those mounds can be 8 meters tall, but it's always a comfortable 30 degrees inside, even when outside it could be 40 to 45 degrees. So animals have come up with solutions to surviving on our planet, and really useful materials that we can copy. So let's move on to net zero. And I know you were talking with Steve Dallas about what net zero is, and I've got a bit of a picture that might be able to help you. So we know humans are releasing these greenhouse gases such as carbon dioxide and methane through burning of fossil fuels and farming practices. We are really good at producing greenhouse gases. The gases trap heat. The reason they're called a greenhouse gas is because they trap heat and warm our planet. And the warming is already causing problems. We've seen huge storms, extreme weather, melting ice caps, and it's harming these beautiful animals and plants. And what this picture really helps explain it from Climate Interactive. We're putting emissions into the atmosphere. Now, historically, plants release carbon dioxide when they degrade. So we've always had these greenhouse gas emissions, and it keeps what makes our planet called the Goldilocks planet. It keeps it lovely and warm. But we've increased the tap flow of these emissions. We're putting more in than our natural systems ever were. So the amount of carbon dioxide and other gases in the atmosphere is rising. And that's making us warmer. So what we need to do is trying to remove as many as possible. Now, the land that we've got, the plants and the animals, places like the Amazon used to be a net removal of carbon through photosynthesis into biomass, into plants and into the soil. But unfortunately, as the planet gets warmer, those plants and the soil is less capable of holding on to onto the carbon dioxide. So we have got a really tricky problem that we need to try and slow down those emissions. Net zero is when we have achieved a balance between the greenhouse gases that we put into the atmosphere with the amount we remove. So it's difficult to remove carbon dioxide. The only way we can really do it is through tree planting, which is essential. We can look after our soils, look after our peatlands, which lock up carbon naturally. We can look at new technologies, well, very old technologies actually, things like biochar, taking carbon material and putting it back in the soil. But the main thing that we can do that really will help us to achieve this net zero balance, so before the bathtub overflows, is to turn off the tap on the emissions, slow it right down, use less energy, make less stuff, and think about how we can do that. So technology is a huge part of the solution. We know that, and many governments are really aiming to reach net zero by 2050. And we can use biomimicry to help us. So already we know that plants are using photosynthesis, those beautiful green leaves. They take in water from the soil, they take in carbon dioxide from the air, and they use sunlight to split water molecules apart, releasing oxygen for us to breathe and storing energy as sugar to help them grow, and they cause no pollution. That's one of the genius things about nature. So how can we use that? Well, we already are. Hydrogen fuel cells. I know today is a lot about hydrogen, and green hydrogen is when we've taken water and copying photosynthesis, we can create hydrogen using sunlight through solar panels and things to split water into hydrogen and oxygen. Hydrogen gas can be stored and used as a clean fuel. And when burned, hydrogen only produces water vapor and zero carbon emissions. So it can be stored and used when the sun isn't shining, and it can definitely help us replace petrol and diesel for our cars and trains and buses, and even for maybe aeroplanes in the future. So we can use processes that we see in nature to help us. I'm going to give you 3 examples, and then we're going to do some creative thinking ourselves, kids. Okay, so sunflowers. I don't know if you've ever seen a field of sunflowers, but they turn their heads to line up with the sun. And engineers have designed solar panels that turn, and they can produce 30% more energy by turning with the sun. Wonderful, using nature for inspiration. Birds and aeroplane wings. If you've ever been on a plane, they have quite often got curled up tips of their plain wings, and that's been based on birds. Here we've got a beautiful owl, and it can reduce fuel up to 5% and make it much more stable flight. Fish schools, those fish, when they see them spinning around, engineers were looking at those and went, that's really efficient way of moving through the water. And so engineers in California have used that model to create wind turbines that optimize efficiency and reduce drag or that friction as they move through the air. And so they're using biological organisms to mimic and create something new. So are you ready? What I want you to do, I'm going to give you 4 minutes for this in a moment. Can nature inspire you to design a wind turbine? Now, I know everybody who's watching this will have seen a wind turbine on hills and pictures. So I've got 6 different things here. We've got a flying squirrel. We've got a sycamore seeds. We've got a bumblebee, which is the flight of a bumblebee is really quite amazing. We've got a bird, a little blue tit. We've got some dandelion seeds, and I've got a flying fish. So your task on your tables is to create, or you can do it on your own, create and sketch a new design of wind turbine based on any of these images or another living organism which inspires you. I'm going to start the timer. I'm going to give you 4 minutes because it's a bit of a task that's going to take some time to think about. Get your pen ready or your pencil ready. You might have whiteboards, you might have paper. So can you design a new wind turbine and explain why you've used the organism you have as inspiration? What can you think that involves flight or movement through air and water that we were doing earlier? And teachers, once your students have got any ideas, you can share them in the chat. Dallas will keep an eye on them for me, hopefully.
Dallas is here, standing by. My brain
Dallas,
is...
you're earning your pennies today.
I am. Actually, Meryl, I just put something in the chat, which is really interesting. I visited a place in Germany called Freiburg, which is a town in Germany. And there's an architect there who built a house, all solar powered, that actually rotates with the sun. So his whole house is on a little turntable, and so the solar panels are always facing the sun. And I thought that's a really good example, exactly as you said, of biomimicry that mimics how sunflowers and flowers move to face the sun. It's in the chat if anyone wants to have a little look at it. It's a wonderful place.
Oh yeah, that's just like those sunflowers. I could quite happily move around with the sun.
Yes, exactly.
I live in the northeast of England, and sometimes
yes.
It's not. But it's beautiful today. It's
always sunny in the northeast. I'm from the northeast, so there you go. And the sun always shines there, never rains.
It absolutely just gorgeous all the time. So we've got 2.5 minutes. I hope you're sketching away and thinking about the animal or plant you might have thought about. Look at those pictures for inspiration. What's your favourite picture there, Dallas?
Well, they're all lovely. I tell you, I brought you in a bird's nest earlier on from my giant hedge. And my hedge is absolutely teeming with life, with small birds, with blue tits and sparrows, house sparrows, robins, of course. And I just love looking at it. I just love watching the birds coming and going and just seeing their busy lives. It's really, really lovely. So that little blue tit you have down there, I think is going to be today's favorite image for me. And I look at that wing and I just see how beautiful and elegant it is as it flares out its feathers it looks like it's about to land on something.
Indeed.
And it's lovely.
It is. It does. It looks like it's got a little insect in its sights.
Yeah.
I think mine's the dandelion. Dandelions, people think that they're weeds, but they're hugely important. They help water run off and get water into soils. You can eat parts of the dandelion. You can eat the leaves. You can eat the roots. And I love just when you see those seeds being blown off at seed dispersal. It's just so beautifully elegant, the design.
Well, isn't it funny? We look in nature and we see design everywhere, and it looks it's almost an illusion. It looks like something has designed it, but of course it's evolution through natural selection, through just this generation after huge amounts of time produces naturally these wonderful structures that all fit together. And I love as you were talking about this idea of the circular economy. There is no waste in nature, and that's the thing that we can take from this.
Yeah, no, absolutely. And that spending time in nature is so good for our well-being. And once you get your eye into thinking, actually, this can also help us with technology. It's not just good to have fresh air and breathe and be interested by identifying plants and animals, but actually they're incredibly clever in terms of how nature's evolved with them. We've got about less than 20 seconds left for your wind turbines. Are we getting anything in the chat with what people have been using for their inspiration, Dallas?
No, because they're all far too
They're
busy
too busy
drawing
drawing.
stuff. They don't
I've,
have time
I've
to.
got
They don't
another
have time
task
to
for them.
chat. If you've got any questions for Meryl about what she's been talking about, absolutely fascinating subject, beautiful images, do put them in the chat box. Keep wanting
Okay,
to say chat box.
and stop right there if you've been drawing. Thank you, Dallas. So hopefully you've been thinking about maybe the shape of an insect wing or the shape of a seed, like a sycamore that flies through the air as it spirals down away from the tree. Because seed dispersal, we want those seeds to get, the tree wants its seeds to be far away as possible, which is why the dandelion's got this really tiny, fluffy little seeds. So hopefully you've done some really good diagrams. Maybe you can send them through to STEM Net Zero if you've got any pictures. But I'm going to move on because that was just a warm up. So, oops, no, she says, right. Okay, so what we want to do is get inventive now. So that was me suggesting a solution for you to get you warmed up. I want you to try and think of one of the issues we've got. We need clean transport. We need to keep warm and insulation. We need clean energy. Those are just three ways, three technology solutions, areas that we need to move towards net zero. You can think of your own problem. You could think about single-use plastic. That's not good for our environment. You could think about how seed pods use their own little shells, and that can then biodegrade. But let's think about just clean transport, keeping warm, and clean energy. And I want you to think about how people can move around without pollution, how we can keep warm without using lots of energy, or how we can use new ways to capture and store renewable energy, or make that renewable energy. And there's some little ideas there in the brackets. We've got birds, dolphins, fish, polar bears, penguins, hibernation, photosynthesis, food storing. Bioluminescence is a strange word. It's where animals create light through their cell actions, or absorbing heat through their surroundings. I think we've all seen some reptiles basking in the sun, so they're absorbing warmth for energy. Your task, you can work in pairs or threes, and on a piece of paper or on your whiteboards, I want you to choose which problem you want to try and solve. Which one interests you, because it's always worth thinking about something that interests you more than some other problems. Find an expert that you can think of. You can look out the window if necessary. Which animal, plant, or natural process solves something similar? Study the solution. What skill, shape, behavior does it have? And design your invention that a natural solution can inspire your technology. You're going to draw it, label it, and show how it works with a sketch, and explain that connection. How does it help us reach net zero? Remember, nature's solutions are usually simple, they use little energy, they create no waste, and they often have really clever shapes or behaviours. I'm going to start this timer because otherwise I'm going to run out of time. You've got 10 minutes to come up with your biomimicry solution to one of our problems. As I say,
Bioluminescence, that's a great word, isn't it?
Bioluminescence, isn't that one of the favourite words? Biological luminescence, giving off light.
So they've got 10 minutes to do this task. Do you want
yes.
we've got a question in. Do you want that now, or should
yes, we could have that now.
Should we have that now? Or I don't want to disturb anyone by talking about interesting things.
I think hopefully their minds are now focused on their task. But if the person who's asked the question, go ahead.
Okay, this is from Mrs. Whitfield again. Thank you, Mrs. Whitfield. She wants to know. It's a good question, actually. Does black and yellow safety tape take inspiration from animals that might be dangerous, such as wasps, bees, and snakes? We had a bee in your picture, so they're black and yellow.
I believe. Yeah, I believe it does. I'm not an expert in hazard safety tape. I was trained as a science teacher and have been a scientist in the past, but definitely those warning signs that you see by the side of the road and safety tape that's black and yellow, I do believe that is a warning because other animals see the black and the yellow and they know that that's a hazard. So things like wasps and bees, because they sting, that would be a warning sign to other animals who might want to eat them. But then other animals mimic them. So a hornet is also black and yellow, but it doesn't have a sting. Some hornets don't have a sting. So actually, animals can mimic each other to try and stay safe. But that's a really good question. I might even do some more research to double check that. But I think the answer is yes.
That is a good question. And now I've been thinking about safety tape as well. And in restaurants, for example, if you cut yourself in a restaurant kitchen, if you're working in a restaurant, you have blue tape, which you put around your finger if you have a little cut. And the reason it's blue is because it's the least occurring color in nature. And
Yep.
so if it falls into the food, you can see it easily.
Yeah, I've heard that one too. I've worked at my fair share of restaurants in my time, and blue. Oh yeah, definitely. When you cut your finger, you have a blue bandage on your finger to show that you've got something that you need to be aware of. So
we've got one more. Here's a question from Mr. E-Man. We teach that animals such as cows release gases that are harmful to the environment. How can this be managed to reduce harm to the planet? Crikey. Yes. So cow burps, actually. People tend to think of cow
burps,
farts,
yeah.
But it's burps.
It's burps. That cows have several stomachs and they burp up methane. So yeah, I work in Northumberland, and I've talked about the problem of farming and cows with students in my classroom, and then farmers have been on the line after school and saying, telling all the kids to go vegan, and I'm not at all. I'm just saying we need to be aware, and that's through learning and through knowledge, that what we eat actually, we talk about healthy diets, but we really need to think about healthy diet for a healthy planet. And so we know beef, if you have a kilogram of beef, it releases in its production, in its growth, and in that cow's lifetime, it will release 60 kilograms of greenhouse gases for every kilogram of beef made. Whereas if you look at something like carrot, it's like 0.04 kilograms of carbon dioxide released. So we obviously can't replace all beef with carrots, but there are lots of things we can eat, which are beans and pulses and things that have a lower carbon footprint but contain as much protein. So I think for me, I always say to people, I say, be aware of what you eat and think about its consequences and its effect on our planet and how that might affect other aspects of nature. And, if you are eating meat, absolutely fine. Make sure it's, good quality if you can afford it. Not everybody can, or just eat a little bit less of it to make sure that you're not, causing more harm than you need through your diet. So I absolutely admit I'm not a vegan. I do eat a little bit of meat now and again, and I enjoy it when I do because I'm eating less of it. So it's a bit of a treat. But things like chocolate as well. Chocolate has got a really high carbon impact. So it's not just beef and the other things we enjoy. It's things that we, every day take for granted a little bit. But cocoa beans are really under threat through climate change. They grow in places around the tropics and extreme weather, too much heat. They're really struggling. So we shouldn't really take anything for granted, I don't think. Kids, you've got 5 more minutes.
That's the message today. Don't take things for granted. I think that's an excellent bit of advice. It's very often because human beings, we do just take things for granted. We get used to behaving in a particular way or eating in a particular way. But also I've noticed that human beings, even though we do get stuck in our ways, change is sometimes very difficult to happen. But when it does happen, it happens, and we're like, I can't believe we used to do that. We get used to things very quickly. I think about things like smoking, for example. Everyone, people used to smoke a generation ago. Now people smoke less, and it's just unacceptable to smoke inside and things like that. So if we can make those changes, which can be sometimes difficult, we'll get used to them very quickly, I think.
Indeed. And then, humans have, we're very inventive. So, after smoking came along vapes. And now we've realized that single-use vapes can cause real problems because they've got batteries in them. So they've got electronic components, which uses resources that aren't easy to replace from nature, from rocks and mining. So, and they can cause fires occasionally. So, it's that, we're learning all the time. Humans are incredibly inventive. We can create things all the time. But even things, we've created fridges, and then that had other problems associated with it because they used to give off gases. So then we had to change the fridge design to work so it's not so polluting. So we're very creative, but sometimes we don't necessarily always think about the long-term consequences. And that's why the circular economy is so important. If you think about how every single lifestyle section of that product that you make or invent, how is it going to be created? How much energy is it going to use? How much, is it going to produce any waste? What can you do with that waste? Can you minimize it? Can you reuse it? So that word waste is something we just need to try and remove out of our, human vernacular, and really talk about how to prevent it at all costs, because getting rid of waste is a nightmare, either landfill or incineration. There's no real best answer. Anyone who's still drawing, coming up with your solutions, have you identified your problem? Have you identified your nature expert that you're going to copy off for biomimicry? Have you designed an invention on it? Have you labelled it and showed how it works with a sketch? And have you explained how it's going to help us reach this net zero? Are you saving energy? Are you trying to keep us warm without using too many materials? Are you trying to design something that helps us move around? You've got 2.5 minutes left. I can't wait to hear about some of these. I think I'm so excited. Hopefully you're all working hard.
I can hear the cogs turning from where I am in the Peak District. Any more questions for Meryl? Get them in the chat, and then I can ask her.
Yeah, superb. Got 2 more minutes.
Meanwhile, I'm watching the birds going crazy outside my window.
Fantastic. Are you feeding them?
I am. I've got some bird food which I put out, and they go absolutely berserk. They're very happy.
I've just started putting out fat balls. I make fat balls with them, but they love it. They absolutely love it at this time of year because it's so cold. You have to make sure.
No, somebody asked, what is there sort of one simple thing you can do at school to help nature? And actually things like looking after your birds, being aware of your birds. There's a wonderful app I have called Merlin.
Merlin, yep.
And I use it every single day, and you turn it on and it records the bird song. It tells you what bird is making that noise. It's great.
So one of the things that one of my team members mentioned the other day, and they worked in schools for many years, a head teacher, and they said, how do we bring nature into school every day? And they came up with a solution, and they take a pot plant, literally a physical pot plant, into every meeting, whether it's with the eco committee, whether it's with the governors, whether it's with the senior leadership team. There is a plant, and that plant has its own seat or its own space at the table. And it's so that everybody's always thinking about nature and climate and sustainability when they're having their meetings. And they could be talking about behaviour, and the plant will be there. And it's like, oh, how does the plant link to behaviour? And it's like, well, okay, if people are getting upset because they've been in the school all day, we all know during wet breaks and everybody's hedged up in the school and everybody gets really sort of fractious and upset. And so actually by having that plant, you can say, right, we definitely need to get kids outside in nature. That green space can be really important. How does, decisions on what we eat in school affect nature? And that's again about maybe eating a little bit less meat, maybe more plant-based food. So having a plant at the table is my top tip that somebody shared with me today to really bring nature into those discussions.
I'm going to have dinner with my plant tonight.
Exactly. I've got my monster plant right next to me. Right, okay. Time is up. I hope that you've enjoyed spending 10 minutes doing some designing and creative thinking. It's connecting you with nature because you're thinking about nature. It's connecting you with technology because you're thinking about solutions to the problems we have. Biomimicry is a beautiful, beautiful art, and one that you can go and study at university if you wanted to, or just to use in your day-to-day life, trying to find solutions. Oops. So, teachers, if you can put anything that you've done, your children have invented in the classroom, that would be great. What problem was being solved? What plant or animal inspired that solution? How does the invention work? And would it actually help us create net zero or protect the environment? And I've put a picture of some trees there just because getting time out in nature is vital for my own mental health, but also for everybody's. It's been shown that time in nature, really connecting with nature, have a conversation with an earthworm is something else somebody suggested I do. And I actually have. I've sat there in my own garden and had a conversation with the earthworm. And it was beautiful. It told me all about its amazing life underground. So what have we learnt today? We have learnt that biomimicry means copying nature's designs to solve problems. Nature has billions of years of research and development that we can use. Natural systems create zero waste and everything gets reused. Evolution creates amazing adaptations that we can learn from. And biomimicry can definitely help us reach net zero emissions. It already is. Things like hydrogen fuel using sunlight is like photosynthesis. Oops, stop. And we need to keep exploring. So get outside in nature whenever you can. What clever, because it can work both ways. You can think of the problem and think of a solution that nature has, or you can think of a piece of nature and think, what can that help me do? So it can work both ways. They might inspire new technology, and then it would be lovely if you went on to think about how you can go into engineering or STEM with your amazing ideas. I'm just going to say one last slide here. I am from the Ministry of Eco-Education, and it's a fully funded framework for big inquiry questions. We have hundreds of questions that we use relating to energy, food, transport, water, waste, society and nature for early years to Key Stage 3. So if anybody wants to get in touch with me, my email address is meryl@ministry.eco, and I think the slides are getting shared with you. So I am going to stop my slides there.
Well, Meryl, thank you very much. The Ministry of Eco-Education. Now, there is a ministry that I like the sound of. So you can get in touch with Meryl and bombard her with questions. We've had a few more actually. Ideas: clothing that we can wear that removes harmful gases based on how plants take out CO2.
Oh.
Well, the artificial trees are kind of a thing. They were a thing, I seem to remember. Living clothing.
Living
like
clothing.
living walls. Why not?
And that fungi we were talking about earlier,
Yeah.
fungi, they're creating fungi leather that you can wear. So absolutely.
Amazing. That's good. I'm going to wear a mushroom hat. Maybe.
You would look handsome as Dallas in your mushroom hat.
I would look very handsome in my giant mushroom hat. Mrs. McKinnell says using plants and buildings to keep the heat. Well, we see that a lot, actually. It's kind of de rigueur to have living walls and living roofs. It's a great idea. I was down in Wales at the weekend, actually, at a place called the Centre for Advanced Technology, and they had lots of kind of living walls and using nature, etc., etc. Listen, Meryl, an absolute joy to have you. Thank you so much. You've given us so much food for thought. And stick around if you can. I don't know. Well, and your plants as well, if they want to join in, and your worm. I'm going to go and have a chat with a woodlouse now.
Fantastic.
Thank you very much indeed. Right, listen, and thank you as well. Just while I've got everyone, and just a huge thanks to RTC North as well for hosting this event. Dawn and Claire and Zara and Sam and everyone, thank you very much indeed. I'm having a great time. Absolutely fascinating talks. It's wonderful. Most of all, thank you to you. Thank you to all the schools. Thank you to all the young people and all the teachers who are with us. I think we've got something like 60 schools logged on, which now makes me feel really under pressure. But thank you very much indeed. Right, our next session is a little bit of a different session. We've got a recorded session for you. We've got a video we're going to play you. And before we play the video, we have got, it's going to lead into a game. You've all heard, I'm sure, of escape rooms where you go into buildings and you have to solve clues in order to get out the other side. Well, we've got our own little escape room version, which we shall talk about in a little while. But before that, let's have our video from Jorden Birch. If we can, with our Microsoft Whisperers. Wow. Okay, so that is the challenge. So you've got to collect numbers. That's the idea of the game. So I just want to check. Are we ready to start? Microsoft Whisperers. Yes. Okay. So this is the game. It's a sustainable escape room, and you have to collect numbers. And what I'm going to do is I'm going to read out the text here, and then you guys can you can see if you can. We'll press the buttons, as it were. Your job is to see if you can solve the clues. Are you ready? Mr. E-Man, thank you. Yes, you're ready. Everyone else ready? Easington Lane Primary School, are you ready? You haven't been let in yet. I should be doing shout outs to all the schools there. Anyway, Newminster Middle School, thank you very much indeed for being here. Right, okay, let's begin. So this is the first slide. Welcome to Sustainable High. You are here to see Sustainable Development Goals in action, and you can't leave unless you figure out the gate combination. Good luck. So you've got to try and solve the numbers. So Zara, why don't we enter the Sustainable Escape Room and see how we get on? Right. Oh, here we are. We're in the school office. Wow. Welcome to Sustainable High. You'll need to solve the clues to escape before the tornado hits. Goodness me. As you visit the classrooms, note the number answer for each clue, and these will match one of the SDGs, which stands for development goals, sustainable development goals, in the poster. So if you look at the poster, you can see these are the United Nations Sustainable Development Goals. Keep these numbers safe, as their sum, i.e. what they add up to, is the combination to exit the building. Good luck. Does that make sense? If it doesn't make sense, or if you're lost, put a thing in the chat and I'll try and unlose you, as it were. So there we go. So what happens next? So Zara's going to, here we go, school corridor, right. Go into each classroom and solve the clues. The answers will be a number that link to one of the Sustainable Development Goals. Crikey. Collect the numbers of your strategies and then total the collected numbers for the code to escape. Right. Go to each classroom. Oh, hang on. Can we go? Oh, crumbs. We've got it. Hang on. Can we go back to that? Okay. Yes. Okay. I just want to make sure that everyone, if that makes sense to everyone. So let me just read that one more time. Go to each classroom, solve the clues. The answer will be a number. I think that's a typo there. That links to one of the Sustainable Development Goals. Collect the numbers of your strategies and then total the collected numbers, add them up, for the code to escape. Okay, right. So where are we going to go? Going to go. Right. Here we go. Right. Okay. You need to look at the image in a textbook. Research the top 4 renewable energy sources used in the UK. Take the first letter and convert letters to numbers, A equals 1, B equals 2, etc. And then divide your final number by 4. Okay, right. I hope I'm doing this right. Maybe Zara can tell me if I'm doing this right. I'm just going to double check. Right, okay. Right, what have we got here? Crumbs. Right, which room are we in? We're in the art room. We're in Mr. Riley's art room. So you need to research. You need a bit of research here. If you look at the picture, what are the top 4 renewable energy sources in the UK? So look at those top 4 energy uses in the UK. Think about what they are. Take the first letter and convert those letters to numbers. So A equals 1, B equals 2, etc. And divide your final number by 4. So I've got the answers here, so I know. Excuse me. So I'm going to keep track of the answers. Don't forget, there's a little notice up there, post-it note. That's a good example of biomimicry, the post-it note. Mrs. Whitfield says, "Oh, son, should I help? Oh, you've added a guide to help. Zara says. She says, I've added a guide to help. I'm not sure where the guide is. Mrs. Whitfield says, sun. Yes, sun is one of them. So you have to work out the numbers. Oh, I see. So if you go into the chat room, Zara's put in a nice guide to help. So A equals 1, B equals 2, C equals 3, etc., etc. So 19 would be the number for S for sun. So sun, I think that's right. I hope this is making sense for people. So we're in Mr. Riley's arts group. Art was my favorite subject at school. I used to love art. Right. Hey, what? We had some strange birds there. We had some pelicans there. I'm not sure what the pelicans were about. Maybe if Zara is there, actually, she can just come on the microphone and just make sure that we're doing this correctly.
Yes, you're doing it correctly.
Are we doing it correctly? Thank you, Zara.
Yes.
Just so
yeah. So there
okay.
are four renewable energies. So if you can be writing the names of the four in the chat, and then we can find the numbers using the chart of the first letter, and then we add all of those numbers up, and then to get the final number, we divide by 4.
You're asking
it's a challenging escape room.
This is a challenging escape room. Now, listen, people are writing in their answers in the chat. Should I read them out? I don't want to give the answers away too quickly.
Yeah, no, please do read them out. That's fine.
Okay, well, wind, someone wants to know. And correct, wind is definitely one of the 4 top renewable energy sources. So woof for wind will have a... Okay, let me work that out. Wind would have a number of... I'm pretending... 23, I think. So wind would be 23. Sun would be 19. What about the other ones? Right. Oh, we've gone into a new... so have you got your 4 numbers down for those ones? Should I read out the numbers? We think wind... Oh, Mr. Mann says, we think wind, solar, hydro, but struggling with the 4th one. Yeah, the 4th one is a tricky one. So I'm looking at that picture there. You're absolutely right. Mr. E. Mann has written down wind, 1, solar, hydro. But what's that 4th one? I'm looking at the thing. I do know what it is, actually. But it's... Shall I pass it on? Shall I write? I'm going to write it in the chat, I think, unless somebody stops me. Okay, I'm writing it in. Boom. It's biofuel, which would have a number corresponding to B would be 2. So you've got wind, you've got sun, you've got hydroelectricity, and you've got biofuel, which adds up to, do some maths here, 52. Divided by 4 equals what does it 13, I think. But I don't want to be helping you. I don't want to. I'm sort of doing this on my own. Right. Okay. Should we move on to the next slide? What do we think? Right. Oh, we're in computing. We're in Mrs. Ayrton's class. Watch the video about flood defences that is on the whiteboard. Write down the first numbers of all the numbers said. And then finally, once you've got all those numbers, divide those numbers by 2. So there's going to be lots of numbers spoken during the video. So you've got to really, really concentrate on the video. Whenever you hear a number, write down the first bit of that number. So if it's like 1,372,000, you'd write down a 1. If it's 58 miles or kilometers, you'd write down a 5. Does that make sense? Hopefully. Right. Okay, let's play the video. Pens and pencils at the ready.
The South Sea Coastal Scheme is the UK's largest local authority-led sea defence scheme. It's over 4.5 kilometres long and costs £175 million. The scheme will look to protect over 10,000 properties and 700 businesses from rising sea levels and increasing storms. So the sea defences at Southsea are nearing the end of their life. They have had a lot of failures over the last 5 or 10 years and really have reached the end of their operational usefulness. So this scheme is really important. By building this scheme, we are protecting the local residents of Southsea for the next 100 years against rising sea levels and increasing storm ferocity. It's fantastic to be able to provide this scheme for the community of Southsea and allow the place for the local residents to be able to come and enjoy the sea and know that their properties are protected.
I think when you've got a project on this size, there's loads of different parties involved. I think day to day you work with electricians, we work with archaeologists, we work with people on the ground, welders. I think there's loads of different people that get involved to create a project like this. For me, I think the project's important. I mean, this is a place I call home. I grew up sort of watching the storms and watching things break because of the storms. So it's nice to see a project that's really going to help bring Southsea to a place where it can protect and actually give Southsea the opportunity to sort of modernise and regenerate, I guess.
I think schemes like Southsea Coastal Development Scheme is really important. It's going to save so many houses and a lot of infrastructure in Portsmouth. And you can see it not just on this project, a lot of other projects where marine infrastructure needs to be higher relative to sea level because of climate change. It's a fact that it's going to happen. So it's not just this project that's going to change the face of the seafront, it's all the other projects as well that's going to be constructed going forward.
Okay, so were you watching carefully? There were lots of numbers. I ticked off a few, but I think I may have missed one. Now, Zara, I don't know about timings, how long we have for this, but maybe we could play the video again because it's fairly short. It's also really interesting. I was too busy watching the video to count all the numbers. Shall we, Zara?
The Southsea Coastal Scheme is the UK's largest local authority-led sea defence scheme. It's over 4.5 kilometres long and costs £175 million. The scheme will look to protect over 10,000 properties and 700 businesses from rising sea levels and increasing storms. So the sea defences at Southsea are nearing the end of their life. They have had a lot of failures over the last 5 or 10 years and really have reached the end of their operational usefulness. So this scheme is really important. By building this scheme, we are protecting the local residents of Southsea for the next 100 years against rising sea levels and increasing storm ferocity. It's fantastic to be able to provide this scheme for the community of Southsea and allow the place for the local residents to be able to come and enjoy the sea and know that their properties are protected.
I think when you've got a project on this size, there's loads of different parties involved. I think day to day you work with electricians, we work with archaeologists, we work with people on the ground, welders. I think there's loads of different people that get involved to create a project like this. For me, I think the project's important. I mean, this is a place I call home. I grew up sort of watching the storms and watching things break because of the storms. So it's nice to see a project that's really going to help bring Southsea to a place where it can protect and actually give Southsea the opportunity to sort of modernise and regenerate, I guess.
I think schemes like Southsea Coastal Development Scheme is really important. It's going to save so many houses and a lot of infrastructure in Portsmouth. And you can see it not just on this project, a lot of other projects where marine infrastructure needs to be higher relative to sea level because of climate change. It's a fact that it's going to happen. So it's not just this project that's going to change the face of the seafront, it's all the other projects as well that's going to be constructed going forward.
Gosh, what an I've been helping you a little bit with the numbers. I put some of the numbers in the chat box if you're interested and are struggling. But sea level, gosh, that's a really interesting. Why is the sea level rising? Well, of course, as the Earth warms up because of the greenhouse gases we're putting into the atmosphere by burning many fossil fuels, it melts some of the ice that's in the polar regions. And of course, particularly in Antarctica, because a lot of that ice is on land. When that ice melts into the sea level will rise. Obviously, ice that's already on the water doesn't really make a difference, except it does, because of course that ice, because it's white, reflects. It acts as a big kind of reflector, reflecting a lot of that sunlight back into space. And as it gets smaller and smaller, the ice, it reflects less and less heat away. And of course, it all melts the ice, and you get this what we call a feedback loop. More ice melting from the land into the sea level rises, and of course, coastal areas like Portsmouth and coastal areas all around the world suffer as a result. Of course, lots and lots of big populated areas are built on coastlines, but and so it's a real problem. Right, sorry, I'm rabbiting on, and I should be helping you escape from the escape room. So we've got Miss Elliott. Same for us. Thanks, Dallas. Good. I thought I was. I may have missed some. So I've got those numbers which are in the chat room. So I make the numbers totaling up to 20. So we take the first number of each of those big numbers. There's always lots of big numbers when we talk about climate change. So 4, 1, 1, 7, 5, and 1 adds up to 20. Divided by 2, 20 divided by 2, even I can do that. It's 10. Going to have, yes, Ringway Primary School. I wasn't copying you. I got that as well. So I'm going to put that in the chat box. There we go, 10. Thank you very much, Ringway. You are all brilliant at Ringway Primary School. We've always known that. Right, okay. Thank you, computing at Mrs. Argon's classroom. Where are we going next? And I hope I'm not taking too long doing all this. I'm a bit lost for time because I don't have timings on my script here. So, oh, Miss Stedman, PE. I'm sure I had a PE teacher called Miss Stedman or Mr. Stedman. I went to Ponteland Middle School and I went to Gosforth Middle School. Right, let's see what the PE Miss Stedman has to say. Right, the recycling bins in the room are overflowing. Well, I suppose that possibly is a good thing. One of those bins cannot be recycled at home. Count how many items are in this bin. Crumbs. How do we know? So let's look at the bin, shall we? So we've got a blue one at the top, paper. Well, we know paper can be recycled. The yellow one is organic matter. So we know that can definitely be recycled. It can be composted down. That's great. Glass can be recycled. As far as I know, glass can be melted down again and returned to make more glass. Plastic, goodness me, plastic can be absolutely recycled. One of the great things I've noticed recently is that the lids on plastic bottles are now attached, so you can't throw them away. And that's really good. And actually, if you think about, if you've got a plastic milk bottle at home, it used to be that if it was semi-skimmed milk, it would be green. And if it was full fat milk, the top would be blue. But those coloured tops didn't used to be able to be recycled. So they would end up in landfill. And now, of course, all milk bottles have the same colour as the milk bottle itself. So it can be recycled. So little simple things like that make a massive difference. So plastic can be recycled. Well, most of it can. Some of it can. Metal can definitely be recycled. You can melt that down again. But what's this one? Hazardous. Crumbs. I don't even know what could be in the hazardous waste. Could be all kinds of terrible things. So I think that is probably the one to look at. And I'm looking to see how many items are in it. 1, 2, 3, 4, 5. Oh, 6. Ringway have got it. Hazardous. Sorry, you're all way ahead of me. Of course, it's hazardous waste. There are 6 items in there. Thank you, Miss Elliott. There are indeed 6 items in there. So that is the answer. The answer is number 6. Oh, Zara has pointed out, thank you, Zara, the prize for winning the escape room is 1 million. It's not 1 million pounds, sadly. It's better than 1 million pounds. It is a STEMunity Spark activity box, which is a kind of box you get with things to do inside, and it's really good. So, so that'll be that. You'll enjoy that. So it's worth winning. Right, you're all far too brilliant for me. You're all getting the answer, it seems to be. Right, our next one, we're in the dance class. Hey, with Miss Edwards. You will notice a video playing on the screen. How many methods are mentioned in the video to help save our water? Hint, have you included the last one? I don't know what that hint means. Let's watch the video and find out. Okay, it didn't have sound, that video, so don't worry if you're panicking, going, why is our sound suddenly gone? It's you just have to kind of read it. So I hope it's clear enough. I hope you've got a screen that's big enough to to see it. I'll just read the thing. So in the video playing, how many methods are mentioned in the video to help save water? So how many methods? You've got to do a little bit of counting. So Zara, if we can play it again. Oh, that's better. There we go. Yeah, now we've got a bit of full screen action. Right, let's play it again. So let's see. And so there we go. There is a very big clue. How many methods can you see there? So count the numbers here. So pick up trash near rivers, lakes and beaches, use less plastic, join a local cleanup event, teach others. There you go. I counted 4 for that one. So I'm going to put that in the chat box. 4. Okay. Thank you. What have we got? Right. Oh, here we go. Here's some more actions. Now let's have a look. Let's have a count. Oh, we missed one there. Okay. Gosh. Miss Elliott got 4 too. The last one I got 4 as well, I think. But it's oh, Zara's replaying it. We can maybe fast forward to it was around about 30 seconds. We're gonna have it all over again. Here we go. Okay. It's only 30 seconds. I hope you're having fun doing this at school. I wonder what you're all doing and whether you're all screaming at the screen. Okay, so 21 seconds. So we got those ones. We got 4 there. Let's see if we can pause it around about 30 seconds. Or here we go. Yes. So how many do we have here? We've got 4 again. Turn off the tap faucet. That's the American word for tap. Avoid wasting water when washing hands. Very good. Recycle plastic bottles and paper. Tell your friends why clean water matters. So there we go. I've got 4 methods. So 4 and 4. So Ringway year 6. Yes, we're at 8 altogether, I think. And finally, now it's your turn. What's one thing you can do to protect water? Write your eco pledge. I promise to blank to help keep our water clean. Well, that is one thing. So 8 plus 1 equals 9. So that, I think, is going to be the number. 8 plus 1 is 9. Thank you, dance class, Miss Edwards. We've got the number there. So I think it's 9 altogether. 4, 4 and 1. Okay, so shall we move on to our next room? What is our next room? Oh, it's Mrs. Reader, the English teacher. Crikey. Okay. Right. You'll notice a book on sustainable travel. It says that. I think that's a typo. It says that Leeds to Manchester is, what's that little squiggly line? It means about, approximately, around. Leeds to Manchester is approximately 50 miles. Which practical option, practical has been put in bold, has the lowest carbon per passenger per kilometer? How many letters are correct in the answer? Right. Okay. Let's have a look. So, well, we've got a car, so you could get probably 4 or 5 people in a car. Well, 1 person on a bicycle and 1 person walking, but it's 50 miles. So 50 miles on that particular bicycle looks like it might be a bit of a challenge. Walking 50 miles, well, you could do it, of course, but it'll take you a while. So it's between those other 3. So we've got a tram, well, we've got a bus and we've got a train, so, and a car. So you can get, I would say you get a lot more people on a train than you would on a bus. And certainly more than in a car. So I'm going to say, well, I'll let you come up with it. Yes, exactly. Miss Whitfield again. Alexandra Smith says 5, train. So it's train and train has 5 letters. Train, T-R-A-I-N, so 5 letters. So I'm going to say the answer is 5. Mrs. Campbell. Hello, Mrs. Campbell. Are you a relation of mine? 5. There we go. I'm gonna go with 5. So there we go. 5 for that one. Right, where are we now? We are in the design tech classroom with Mrs. Martin. Hello, Mrs. Martin. You notice on the whiteboard a multiple choice question. How many words are in the correct answer? So let's have a look at the question. Why are aluminium cans, such as this peach soda can pictured, considered sustainable packaging? They are recyclable, quick decomposition, they are renewable, or all of the above. Well, let's have a think about this. It's aluminium. So what is aluminium? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. It's in the periodic table of elements. So it's actually a metal, aluminium. Of course, you know that. And drinks cans are made of it. Funnily enough, aluminium back in the day, back in the 1800s, used to be one of the most expensive metals in the world. It was more expensive than gold. Now, of course, we use it for everything: aluminium, tin foil, and certainly soda cans. Is it will it decompose if you bury it in the ground? I don't think so. So that gets rid of quick decomposition and all of the above. They're renewable. Well, in a sense, but they certainly are recyclable. So I am going to say they are recyclable. So total words of they are recyclable is 3. If we're counting are as a word, because the other ones have got there. Is that one word? Or Zara, maybe you can help us out here. I'm saying it is 3 for total words. Am I right? Yes, so the answer is 3. They are recyclable. Unless the recyclable is counting as a word, in which case it's 4. But I think it's 3, so I'm going to put in 3 in there. Okay. Great. Okay, our next one, we're in food tech with Mr. Crutchfield. Grumpy Crutchfield, we used to call him at school. Right, you notice on the computer that it is better for the environment to source food locally and use food that is in season. How many of the following foods can be grown locally? Now, I'm saying locally, I don't know where you all are. The Northeast, I know a lot of people are here from the Northeast, which is my part of the world. So let's say it's the Northeast. So what do we think? What have we got here? Well, bananas. Do bananas grow in the northeast of England? I'm saying no. I'm saying bananas grow in hotter climate. Caribbean, for example, places like that. African countries, places like that. What about that one at the top? Is that a mango? It looks like a mango. Again, doesn't grow very well in the UK. Obviously, it might grow in a greenhouse, but it's certainly not a local specialty of the UK. Strawberries, on the other hand, now I had a bumper strawberry crop this year, amazing amount of strawberries, but I didn't have them in November and December. I had them in the summertime, so certainly not in this season. I had them in the summer, and here we are in the middle of, well, back end of autumn into winter. So I'm going to rule out strawberries. Avocado, again, I love avocado because I'm a hipster and I like my smashed avocado on toast. But they certainly do not grow in the UK. And avocados actually use an incredible amount of water that they grow in South America and in North America as well, southern states of North America, as far as I know. So I'm saying no for those. But on the other hand, apples and potatoes, they definitely grow in the UK, and they definitely grow well. We've come into the end of apple season, so depending on what season we're talking about, definitely apples. We've had loads of apples this year, loads of potatoes as well this year. So apples and potatoes, definitely. Perhaps strawberries as well. It's a difficult one because strawberries are much more of a summer fruit, but it's either 2 or 3. I'm going to ask Zara for help on this one. Is it 2 or is it 3? Depending on how, because I don't want to mess up people's numbering. It's 3. Okay. Well, Mrs. Whitfield says it's 3, so I'm gonna agree with her. Ringway Primary School, and who are we to argue with Ringway Primary School? We think 3. Some of the children have discussed going strawberry picking. Others have mentioned having apple trees in their garden. And Zara says it's 3. Okay, it's 3. I'm going for 3, even though my strawberries are well past their sell-by date. Apples, potatoes, strawberries. So 3 is the answer for that. Right, we're going to whiz over to history. Mr. Gardner, you notice an old container on the floor and you remember the following tips about how to recycle it. How many letters are in the missing word? What is the missing word? Cardboard boxes should be flattened and blank before recycling to ensure they're not contaminated with food. Goodness, so cardboard boxes should be flattened and something before recycling to ensure they're not contaminated with food. Well, so we imagine a cardboard box and imagine it's had lots of food in it. Maybe it's an old fruit cardboard box and some of that fruit has got all over the cardboard, so it's a bit messy and a bit grim and a bit sticky and nasty. We've got to flatten it because when we flatten it, it takes up less space and then we can more easily put it into our recycling box. But what else are we going to do to it? It needs to be blank. What would you do if you saw a cardboard box that was covered in old food that maybe it's gone a bit rotten, it's starting to smell a little bit? Good question. Cleaned? Emptied? Well, okay. Thank you, Miss Elliott. It's a really good question. Let's assume that there's no food in the box, so the box is empty, so it's already emptied. So I think your Ringway year 6 is a good one. Yeah, they want to know, is it being checked? Well, let's assume we've checked it. Hint, if you count the circles, you can get the correct answers. So let's CHECKED. So checked would fit, but I don't think it's checked. I'm imagining sort of it's a little bit dirty, sprayed. Basically, there's a lot of 1, 2, 3, 4, 5, 6, 7 letter words which could apply to this one. But I know the yeah, I think you're right. I think it's clean. It's going to go in there, but they would all work. They would all your ideas would work. Sprayed, clean. Basically, we want to clean it. So yeah. So 7, of course, is the correct answer for that. Right. Okay, we're in maths with Miss Ali. You'll find an old worksheet. How many answers are true? Multiply this number by 2. Crumbs. I'm struggling to see because it's so small. Okay. You'll find an old worksheet. How many answers are true? Earth offers a variety of habitats and landscapes. We've only 8 minutes before the tornado hits. Okay, hang on. Let's go through this really, really quickly. Okay, so that's true. I can't even read it because it's too small for me to read. I can't read, everything's been printed out, so I can't read it on my script because it's also too small. Is it home to a few plants and animals? Well, I think that's loads of plants and animals. Our planet provides us. Well, I'm going to let you read it because I can't read it because unfortunately it's too small for me to read. But I have the answer here. I have the answer here. And remember, whatever the answer is, we have to multiply that number by 2, so we have to double it. Zara, do not worry. She can't make it bigger, unfortunately. That's okay. But maybe at your schools, you've got a big screen where you can read it. I can just about read some of them. We are Mrs. Whitfield's reading it. We're reading it and think 7 are correct. Well, okay, 7. So 7 multiplied by 2 is 14, as far as I know. So the answer is 14, I think. I hope you had the chance to kind of go through some of those. They're all really good questions. That's the answer, I think. And I'm going to because we've only got about 5 minutes before the tornado hits. Science, Mr. Al-Khalili. Is that Jim Al-Khalili? My friend Jim Al-Khalili, who I work with sometimes. You notice a poster on the wall. What do all of the images represent? How many letters are in that word? Multiply it by 2. Wow. Okay. They all represent. Oh, what do they represent? Well, they're all people doing something. So we've got someone planting a tree. So that looks like a farmer. We've got somebody. Well, down at the bottom, we've got someone looking for a microscope. So she's a scientist. We've got people diving and they're measuring some plants underwater. So they're underwater scientists. Are they looking? And we've got a woman up there who looks, she's got something in her hand, which I can't see what it is, but she looks like she's an engineer. I can tell that because she's kind of wearing a hard hat. So we've got an engineer, a gardener, and an underwater scientist, and she looks like maybe she's a chemist or something. What are they all doing? They're looking at things, but they all represent, what do you do when you leave school? When you leave university, you get a job. So jobs, I think, is the key thing there. So jobs, J-O-B-S, 4 letters, multiplied by 2 is 8. There we go. I'm going to put that in. There we go. So jobs is the one. Hopefully we are getting, okay, so this is, where are we now? Right, we've got the wrong room. If you sneak out now, then you can leave without our guest teacher noticing. Not quite sure what's going on here. Oh, we're reading 7. Oh, reading, I think it's 7. Oh, are we ready to leave? Crumbs. Are we ready to leave? Okay. So you have to add up all those codes before the tornado which is hit, which is imminently. So what do you have? I'm going to let you put in the numbers, and then if you put the numbers in the box, I'll see if they're correct. So there is a number to put in, and then if you put it in and press exit, you win a massive prize, which isn't £1 million. So I'll just give you a minute to have a little think about that. Now I've got a number here, so I think it's correct. So I've been going back through my bits of paper to see if I've got it right. I think I've got it, but I'm not going to put it in until Zara tells me to put it in which case I will. Or Dawn, or Claire, or somebody from RTC North. We've got new messages. Now, well, a lot of people have put in, well, we've got Ringway have put in 78 and David Winters put in 78. I think you may be a couple off. That's a little bit of a clue. I'm just going to go back and look at my numbers. I will check. Easington Lane have 88. You're all roughly in the right ballpark. So let me just do a little bit of mental maths here. 13, 23. Sorry, I'm doing mental maths here. Talking amongst yourselves. Oh, I think we've missed out a slide here. I think we've missed out Mr. White's slide on the school corridor. Yeah, I think we have. Mr. White, click on the school corridor button and click on science. Here we go. Yeah, we missed this one out. There we go. You see a receipt on the floor. Calculate if a family earning £250, sorry, better maths for you, £250 a week can afford a basket costing £200 a week after paying £55 for rent. Hang on a sec, let me just get my head around this. You see a receipt on the floor, okay. Calculate if a family earning £250 a week can afford a basket, I'm guessing a basket of groceries, costing £200 a week after paying £55 a week for rent. If yes, they are above the poverty line. If no, they're below the poverty line. I think that's a typo. If they're below, oh, I see. If yes, they are above the poverty line. If no, they are below. Oh, I see. There meant to be a full stop there, I think. The answer is 1 if yes, they are above the poverty line. Oh, I think I'm reading that wrong. Sorry, can you read that for me? I'm reading it completely wrong. I think it's 1. Yeah. If yes, they are above the poverty line. If no, they are below. Answer is 1. If yes, they are above, and the answer is 2. Ah, okay, so it's 1. Yes, I see. Oh, okay. So you've all right. Ringway, 80. Sam, 80. Miss Elliott, 80. Easington Lane Primary School, the great Easington Lane Primary School. 80. You've all got 80, and I'm just doing my maths. Thank you for that extra slide. The correct answer, ladies and gentlemen, is, drum roll please, 80. Hey, we've escaped. Congratulations. We get a certificate. Wow, we get to escape the escape room. I enjoyed that. Despite my poor mathematics, I enjoyed that very much indeed. We escaped the room. We've been saved from the dreaded tornado, I think. I think we have anyway. So there we go. How are we doing for time? It is 11:30. Right. Okay. We're going to have to move on. Thank you very much for everyone who took part in our escape room. Wow, the tension doing that was palpable. It certainly was where I'm sitting. My poor brain needs a rest. Right, we're going to talk about hydrogen next. And we've got REHIP, who are going to be taking our next session. So thank you very much for that. And this is all about hydrogen and future careers. And I think this is a really, really interesting subject. It's the Research England Hydrogen Innovation Project. And of course, if you're from the Northeast, you might know that a lot of investment has gone into hydrogen in the Northeast. But what the heck is hydrogen? Why do we care about hydrogen? Why is this an important thing? Well, this is what we're going to find out. So who have we got speaking? I'm not sure, actually. Who do we have? We've got someone there, but she's on mute.
Hello, everyone. My name is Adi from Durham University, alongside with my colleagues Alessandro and Claire. Alessandro, if you want, you can go on, and then I will continue.
Thank you, Alessandro and Claire. What a pleasure. Now, I know that Durham University, I know that Teesside University are involved in this, as well as the Research England Hydrogen Innovation Project, which has been a big thing in the Northeast. So tell us all about hydrogen. What's it all about? And you're going to tell us a little bit about careers as well. So I'm going to hop off my mic and my camera, and I will leave it in your capable hydrogen hands.
Yeah, thank you very much. My name is Hadi, a researcher from Durham University. Welcome, everyone, and thank you for joining today's session as part of STEM Net Zero 2025. Today, we're gonna, together with my colleagues, Claire and Alessandro, we're gonna explore one of the most exciting developments in the clean energy transition, which is hydrogen, and see how it connects to future careers here in the Tees Valley. This presentation highlights our work within the Research England Hydrogen Innovation Project, or known as REHIP, a major initiative supporting research, innovation, and careers in the hydrogen sector. We'll look at the region's innovation and career in the hydrogen sector. For agenda that we have for this session, first we'll start with a quick interactive quiz to test your existing knowledge about hydrogen, to see what hydrogen is, how it's supported, how it's produced, and why it's important to net zero. Next, we'll move into a live demo of hydrogen production. You'll be able to see how hydrogen can be generated through electrolysis and learn the simple chemistry behind it. And finally, we'll discuss future career opportunities in the hydrogen and green energy sectors, especially within the Tees Valley. Well, let's deep dive into REHIP project, which I'm also involved in this project for 2 years. The REHIP project is a major 4-year, £11 million initiative that brings together the strength of Teesside University and Durham University. Its purpose is to accelerate innovation and build capacity in hydrogen technology across the Tees Valley. One of our primary goals is to support a just transition, ensuring the local communities and workforce equally benefit from the move towards net zero energy systems. REHIP focuses on four main thematic areas: industrial heat, transportation, smart energy, and just transition. Through research, pilot projects, and educational outreach, REHIP aims to make the Tees Valley a central player in the UK hydrogen economy. In this picture, which shows the Tees Valley, the question arises that why Tees Valley has to be the central point for hydrogen development? Well, the answer is because it's perfectly located for easy access to the whole of the UK, with fast rail links to London and Edinburgh, international airports, and one of the UK's deepest ports. This map gives a sense of how interconnected the industrial clusters are. Ports, rail, manufacturing, and heavy industry all sit within a short distance. This proximity is a major advantage and drive for scaling hydrogen production and distribution. In the next slide, we see that we have the second view highlight the industrial footprint of the region. Tees Valley is home to one of the UK's primary chemical and processing clusters. Beyond location, Tees Valley is a thriving community. Over 2.5 million people live within an hour's drive. It's home to 6 major universities. The most prominent ones are Teesside University, Durham University, Newcastle, and Leeds. In the next slide, we see a picture of the old Tees Valley with its industrial location and the picture of the Tees Valley. So to understand the region's hydrogen future, we also need to understand its past. Tees Valley was once known as Victorian Ironopolis, a global center for iron, steel, chemical production, and engineering. This industrial strength laid the foundation for the modern chemical and process industries we see today. Even now, the region produces about 50% of the hydrogen used in the UK chemical industry, although it's mostly from carbon-intensive methods. However, as heavy industry has declined, new opportunities have emerged. In the next slide, we have one of the projects in the REHIP, one example of applied hydrogen research, that is Fish Cup project, and it explores whether hydrogen-powered vehicle can be integrated into police operation. Police fleets are challenging to decarbonize because they require long range, rapid refueling, and high reliability. Here in this video, Sean elaborates more on the project's horizon.
In partnership with Durham University, as part of the Research England Hydrogen Innovation Project, we're working together with Cleveland Police and Simon Bales on a project that aims to investigate the feasibility of introducing hydrogen fuel vehicles into police fleet operations. So fleet decarbonisation presents some unique challenges for fleet operators, emergency services and construction site vehicles. A fleet consisting of battery electric vehicles is not necessarily the right answer. So when we make a comparison against battery electric vehicles, hydrogen as a fuel type offers some distinct advantages. Improved refueling times, range, and also better performance in cold weather conditions too. The Northern Zero Emissions Vehicle Symposium is brought to you by Teesside University, working in partnership with the Tees Valley Combined Authority. So the event is all about bringing a spotlight to hydrogen and using sandpit activities to turn ideas into action.
We look at the electric vehicle as the example. What's happened over the last 20 years, and it's been such a short period of time, is that we've got very credible vehicles now. So hydrogen will have a place, but we actually need to recognise that we need to put major infrastructure in place to make it work and make it credible before manufacturers start really investing in the development. All the technology's there, but it's how do we implement that?
So this particular project is supported by the UKRI, so it's taxpayers. So therefore, we keen really to develop strategies and plans for the future, which industry are leading or coming on board, and that's the excitement mixing academia, new knowledge and understanding with industry application.
So we all have a vital role to play, including government, to ensure hydrogen has a viable place in the energy mix to help us all achieve that fleet decarbonisation targets.
Thank you. Over to you, Alessandro.
Thanks, Adi, for the nice introduction. And now is the second part of the presentation. We're going to take a short multiple answer quiz. One of the things is that more than one answer might be correct. There should be the poll function active for the quiz, otherwise you can put your answer in the chat box. So for the first question is, what is actually hydrogen? Is A, a metal that is solid at room temperature, a very light and colorless gas, the most common element found in the universe, or a rock used to make cement? I'll give you a few seconds to answer.
I think I gave away the answer in my introduction, so I apologize.
There will be more questions, more in details. Yes. Yeah, okay, so we start having an idea. The correct ones are B and C. In terms of hydrogen is a very light and colorless gas. Is the most common, but is also the most common element found in the universe. Here I'll give you a statistic. If we weight all the atoms all over the universe, the amount of hydrogen will be about 3/4 of the total. So it's quite significant amount. And the next question is related to this, is like where we can find hydrogen. Only mountains, option A. Only as pure hydrogen in the air. C, in the sun and the stars. And D, in water. Okay, so we're getting a mixture of C and D, and which are the correct ones. So hydrogen on planet Earth is mostly found in water, as we know, H2O, as it was mentioned. So 2 atoms of hydrogen and 1 atom of oxygen. But also is, as we said, is the most common element in the universe, is found in the sun and in the stars, and is actually the fuel of the stars that creates all this reaction that gives produce the energy that gives energy to us, this sunlight. So the third question is why so we are investigating hydrogen? Why is hydrogen important for clean energy and transportation? The answer A is it can help make cleaner energy and transportation with less air pollution. It produces more rubbish. It can make cars go faster. And it's important because it doesn't need any safety rules. Yeah, I think we're getting there. So yeah, well done. This was clear. And hydrogen is important because it can give us clean energy and transportation with much less air pollution. It's important here to notice regarding the safety rules that hydrogen is a different fuel than natural gas or petrol, for example. As such, it's important to handle it with safety rules such as for the other fuels, and system needs to be engineered in a way that accommodate hydrogen. Therefore, research is investigating how to safely handle this new type of fuel. So for question, we move into the transportation as we've seen before for Sean's and Fishcop video. What is a zero emission vehicle? A car that burns petrol or diesel efficiently. B, a car that uses renewable electricity or hydrogen. C, a lorry that runs on diesel. And D, a car that doesn't make any pollution from its tailpipe. Nice one, Dallas. Yeah, so I think we got enough answers. Yeah, and we are around B and D, which is correct. So the definition of a zero emission vehicle is a vehicle that doesn't make any pollution from its tailpipe. In this regard, battery electric vehicles or hydrogen vehicles, in particular if using renewable electricity, they represent a type of zero emission vehicle. On the other hand, if we have vehicles that runs on petrol or diesel, they are responsible for the emission of carbon dioxide, which as we know is a pollutant, a greenhouse gas. And therefore we want to reduce it, even though some new engines are burning them more efficiently, there will be still an emission of carbon dioxide. So now we move to the question 5. What powers hydrogen car? And that's A, hydrogen gas, B, a fuel cell that turns hydrogen into electricity, C, an electric motor that drives the wheels, and D, petrol burned in an engine. This might be a tricky one. So I'm curious to see the answers.
It's a really good question. It's not obvious. It's the question that always surprises people, I think, when they understand how a hydrogen car works.
Exactly. Let's give it a few seconds more. Okay, so I can see one is correct and is actually A, B, and C. So these 3 correct answers represent 3 different parts of the hydrogen car. The hydrogen gas, hydrogen is the fuel. This fuel is then used with a fuel cell that turns hydrogen into electricity, and then this electricity is then used in an electric motor that actually drives the wheels. Well done. And the last question is, what mainly comes out of the exhaust of a hydrogen fuel cell car? Option A, smoke. Option B, carbon dioxide. Option C, mostly water vapor. Or option D, unburned petrol. Maybe. Yeah, we are there. We got it right. It's mostly water vapor. As we said, inside the fuel cell, the hydrogen reacts with oxygen from the air to produce electricity and water. Electricity is then used to actually move the car, while the water vapor is exhausted. It's the only exhaust, so therefore we have a case of zero emission vehicle. So now that we have know a bit more, we've tested your knowledge around hydrogen, which was perfect, very good, well done. We have a video of two of my colleagues from Teesside University that will show an example of a hydrogen demonstrator in action that is at the Net Zero Laboratory at Teesside University.
Welcome everyone. I'm Dr. Makbul and this is Dr. Prasad. We have very interesting setup here today. It's look like a science experiment, but I have been told it represents the future of energy. Prasad, can you please tell us what we are looking at today?
Absolutely, Makbul. So this is the hydrogen demonstrator at Net Zero Industry Innovation Center, Teesside University. So you can consider this as a miniature of renewable energy plant. So it demonstrates the entire hydrogen cycle, its production, its storage, and usage of it.
Thank you very much, Prasad. I see these solar panels, water tanks, and all these wiring. Can you please explain how this circle works?
Yes, Makbul. So it all starts with the sun, but in our case, it is the lamp. The solar panel converts light energy into electricity, but here there's a problem. You know that solar power is not continuous. We call it is intermittent. So we know that sun doesn't shine at night. So we need to demonstrate a method by which we can store that energy.
Oh, thank you. So we are not charging battery here?
No batteries at all. So we are using that solar electricity to power this component, which is known as electrolyzer.
Oh, thank you. I can see the water is boiling. Is actually the water boiling?
No, it's not boiling water. It's actually bubbles coming out of water. Basically, we are breaking water into hydrogen and oxygen. We know that the chemical formula of water is H2O. It contains 2 hydrogen atoms and 1 oxygen atom. In this system, the electricity physically pulls out water into hydrogen and oxygen. The bubbles on one side is hydrogen, the other side is oxygen. And this process is called electrolysis of water. And electrolysis of water, we get green hydrogen.
Thank you very much. I noticed one cylinder has less gas as compared to the second cylinder. Do you think why it is? I could not catch it.
Oh, great observation, Makbul. Look at the formula of water. So that is H2O. So there are 2 hydrogen atoms for every 1 oxygen atom. So we produce exactly twice as much of hydrogen compared to oxygen.
That's great. Okay, so now we have trapped the energy in the form of hydrogen gas. How do we get the electricity back out to run a motor?
So consider we stop the solar power. And when I connect the tubes on the tanks, these tubes on the tanks to another device, this is called fuel cell. That is a magic box basically. It takes hydrogen and oxygen from the other side and combines them.
Oh, thank you. It's looking interesting. Does it burn the hydrogen?
No. Burning is actually dirty and inefficient. A fuel cell does something called cold combustion. That is actually an electrochemical reaction. It chemically forces hydrogen and oxygen to rejoin. And as they meet each other, it produces electrons. And these electrons are forced to the circuit to produce electricity.
Sound interesting. So, the byproduct is just water?
Exactly. So what we are doing here in the fuel cell is just what we did the opposite here. Here the only exhaust is water. There is no carbon, no smoke, no pollution. That's why we call hydrogen as a clean future fuel.
Thank you very much. This seems perfect for the environment. Is it safe to have hydrogen in a classroom? I have heard hydrogen is very explosive.
This is a common concern for all of us. In large amounts, when we mix hydrogen and oxygen or air, hydrogen is flammable. However, in this demonstrator, we are using very small amounts of hydrogen, and always we keep hydrogen and oxygen in separate cylinders, and the pressure is also very low. So as long as we keep any ignition source away from these gases, this is very safe to use in a classroom environment under supervision.
Thank you, Parsa. Does it require special maintenance?
No, very little maintenance is needed. The most common rule is always fill distilled water or deionized water in these compartments, because the electrolyzer, it contains a membrane. So if we fill tap water in it, tap water contains minerals that will clog the membrane and that will damage the membrane.
Absolutely, thank you. What is the main takeaway you want people to learn from this kit?
So I want the students to understand the concept of energy storage. We know solar and wind are great, they are renewable, but they are intermittent. Hydrogen allows us a way to store the sun's energy in a bottle basically, and we can use it whenever and wherever we need it in a cleaner way.
Thank you so much for the nice demonstration, Prasad.
Thank you, Makbul.
Thank you very much for your patience and listening to us. So, me and Dr. Prasad, we both are available for you at your earliest convenience. So, whenever you want to ask any questions, please don't hesitate to reach us. Thank you very much.
Thank you all.
So, very nice video. I hope you liked it, and now I'll pass it to Claire, my colleague from Teesside University, for the last part of the presentation about green skills and careers in Tees Valley.
Thanks, Alexandra. Hello, everybody. My name is Claire. I'm also a research fellow at Teesside University, where my work focuses on skills and just transitions. Can you move to the next slide, Alexandra, please? So what am I going to talk to you about today? Well, I'm going to talk to you about what are green skills, why the Tees Valley, and what different types of job opportunities might be coming available. So first of all, what do we mean by green skills? Well, green skills are the knowledge and the ability that we need to help build, design, or run a clean technology plant to reduce carbon emissions, but also remove harmful chemicals from the air's atmosphere. The Tees Valley is an important place where a lot of industry is based. That industry is based on old technology, which means that it uses an awful lot of energy and emits a lot of carbon. But things are changing. We have a long and very rich industrial past. In the past, we've had companies like ICI
manufacturing chemicals, British Steel manufacturing steel, which has sadly declined. But much of the infrastructure, so things like the pipework, the network, port, and other transport infrastructure is still there and still used by industry today. And we also have one of the largest offshore wind farms over at Dogger Bank. Your mums and dads might have heard, seen on the news recently, there's been lots of different announcements in relation to investment in the Tees Valley. There are plans to build huge industrial plant that will produce what we call sustainable aviation fuel, and that's a clean fuel type that will replace jet fuel. There's a company called Alphanar looking to build a huge plant on Sea Sands, which is close to Hartlepool on the Tees estuary. We're also building a carbon capture plant, more plans to build more wind energy, and also small nuclear reactors. And these will be built over the next 10 to 20 years. But the work on that is starting now with groundwork, like preparing the ground, with planning applications, doing all the regulations. So that's work that the Environment Agency does to make sure that industry isn't emitting any harmful chemicals. So there are going to be huge opportunities for you in the future to work in the clean energy sector to help address climate change and protect the environment. Can you just move on to the next slide, please? So what kind of opportunities are available on the Tees Valley? Well, I talked about, the Tees Valley's industrial past and the fact that a lot of industry is really hard to do what we call decarbonisation. So that's reducing the amount of carbon that the industry emits. But Tees Valley has been identified as what we call an industrial cluster. So that's a place where clean industry, clean technology is going to be concentrated. So the area is going to be one of the first transport hubs for hydrogen. So that's a place where hydrogen refueling and other transport infrastructure is going to be concentrated. And you saw in the video the work that Dr. Sean Williams is doing, working alongside Cleveland Police. We've also got 5 companies who are looking to invest in sustainable aviation fuel. I mentioned the work of Alphanar, but at the Net Zero Industry Innovation Centre, where myself and some of the colleagues on the presentation today are based, we're also working with a company that's looking at how they can use eggshells that are disused from baking processes to make sustainable aviation fuel too. In Hartlepool, we're looking to build small nuclear reactors as well as decommission the existing infrastructure there, and together that's driving the economic growth and sustainable and trying to sustain and create lots of new opportunities for the clean energy industry across technical roles and also managerial roles, but we also need lots of other people to support those industries too. And I want to, that's where I'm going to kind of focus my this talk next. Can you move on to the next slide, please? So what types of job roles are going to be available? Well, there's going to be lots of technical engineering roles, or technicians to support the running of plants and the maintenance of plants, but also mechanical, electrical and chemical engineers. We also need to continue to evolve and develop the technology so that it becomes more efficient and can remove more carbon. So there'll be opportunities for research and development in hydrogen, but also other forms of clean technology, including sustainable aviation fuel processes. We need project managers who can help make sure that these plants are built on time, and people who can analyze data, so people with computer science background, cybersecurity, but we also need lots of other roles too. So, we need people to look after those workers. So it'll be doctors, nurses, hairdressers, teachers, nursery nurse workers, people who work in retail and hospitality, to help feed these people. There's lots of different opportunities that are going to be available across the entire, what we call the supply chain of clean energy. So that's not just the plants themselves, it's all the component parts, the construction of them. So what kind of skills do you need for these roles? Can you just move on to the next slide, please? So STEM qualifications, so things like physics, chemistry, biology and maths, English too, being able to use a computer is also important, and having an awareness of sustainability and protecting the environment. Something called health and safety is also in compliance or regulation. So that's all the standards that companies have to follow to make sure that, running a clean technology plant is safe for everybody. These are not things that you need to worry about just now, but when you eventually finish secondary school and you're thinking about going to technical college or doing A levels or an apprenticeship, that's the kind of point at which you'd start to learn about these things. So can we move on to the next slide, please? So I mentioned that there are lots of other supporting roles. So in addition to kind of doing engineering, we also need lots of people to help make and design and create the steel components and the parts for wind turbines, for hydrogen storage, the equipment that's used to manufacture and create things like sustainable aviation fuel. But we also need construction workers, lots of tradespeople, electricians, bricklayers, pipe fitters and welders, that can help build the plants that we need to make sure that those sites become operational as soon as they can to help address the climate crisis. So you've heard about our research today. Can you just move on to the next slide, please? As a research team at Durham and Teesside University, we don't just do the research, we also go out into schools and colleges with STEM ambassadors, and you saw Prasanth and Makbul in the video doing a demonstration of the electrolyzer. We also have hands-on workshops where you can create hydrogen yourself in a very, very small scale experiment. We've developed workshops whereby you can design your own hydrogen car or another type of vehicle. You can see that here. There's workshops where you can figure out how you're going to get excess heat from a plant that can be reused and recycled and used to heat your school or your college or community building. There's lots of different opportunities for you to learn more about hydrogen and the work that we're doing. So please feel free to reach out and get in touch with us about that. Can we move on to the last and final slide, please? I think there was another one. Move one before? Maybe not. No, we've missed the slide. So there was another slide, and basically that just said that if you are interested in a career in clean technology, you know, what should you do next? Well, continue working hard with your hard at school, particularly with your science, maths and English subjects. But also, I know it's a bit of a way off, but take a look at Teesside and Durham University's website, and you'll see that we have lots of opportunities for degree apprenticeships, degree programs and other courses that will give you a kind of idea of some of the opportunities and that are going to be coming available, that can mean that you can have a career in industry that will not only help industry reduce the amount of carbon that it emits into the atmosphere, but also protect the natural environment. Thank you very much, and I hope that you enjoyed listening.
Well, we enjoyed listening to that very much indeed. Thank you very, very much, team. First of all, well, thank you very much to Durham University, Teesside University. I think hydrogen's an absolutely, well, first of all, from the science point of view, I think it's really, really fantastic. We hear a lot about electric cars, and of course, hydrogen is this alternative. And if we can make hydrogen cleanly, as we discussed, then it could be a game changer in lots of different ways. Particularly, I think, Alexandra, in terms of things that are areas that are hard to electrify. So things like big shipping, for example, I could imagine hydrogen being used, or cement production, or those big heavy industry things. It seems like it could be a real game changer.
Yes, like trucks is another potential applications because of the limit that the large batteries puts on the weight of the truck. So that's another potential application. Yeah, shipping, aviation. They're investigating some form of hydrogen, or as direct use of hydrogen, or as Claire mentioned, sustainable aviation fuels, or mixing it with ammonia for use in ships. So there is a big potential in different sectors, or just as ammonia as fertilizer, like clean the production of ammonia for the fertilization will have a huge impact.
Great. Well, listen, thank you very much, and Claire, thank you very much as well for your tips on careers in this area. I'm going to go and study harder at maths and science now. I'm going to, we need good creative people in this industry, particularly in the northeast. The northeast is a real trailblazer in this area. So thank you very much. Now then, we are about to go for lunch. We've got a half-hour lunch break. We start again at 1 o'clock, so we've got a 45-minute lunch break. Just before we go to lunch, ladies and gents, we've got a video from Nigel Topping, who's the chair of the Climate Change Committee, just for us, especially for the Teesside University and Durham University and their REHIP programme today. So thank you for this video. Again, thank you to all of these people along here that you can see, particularly RTC North. Thank you to them for being so brilliant. So here's Nigel, and after the video, we'll go straight to lunch and we'll see you back here 1 o'clock sharp, not 1:01, 1 o'clock.
Hello, my name is Nigel Topping. I'm chair of the UK
Hooray for lunch. We'll see you back here at 1 o'clock, 1 o'clock prompt.
twice I've done that. I think that's hers. Yeah, look, that's just how we need to share. Oh, we haven't shared yet. No, I like a little sleep.
Hi, everyone. Welcome back from lunch. If you're there, welcome back. Thank you very much to everyone who joined us this morning. We had a wonderful session this morning. We covered all kinds of things. We covered things like biomimicry. We covered things like hydrogen. We discussed what net zero means. We thought about all kinds of different things. And I hope your classes, wherever you are, took some good things for that. We also had an exciting escape room. And I'm not sure who actually won our escape room prize, but there you go. And it wasn't £1 million, so I apologise for that. Right, we're going to crack on this afternoon. We've got some more fantastic speakers. Welcome if you've just joined us. I think maybe the whole session has been recorded, so perhaps if you like, you'd be able to watch some of it back if you missed any of the sessions a little bit later on. Right, so who have we got this time? We've got Tracy Johnson and Laura Baines, who are going to be talking to us now. We've also, I think, have I said the right people? Have we got, is it Tracy and Laura?
Tracy, Laura, and we've also got Julie with us today as well.
Oh, and Julie as well. Hello, Tracy, Laura, and Julie. Now, remind us what you're talking about. You're going to be talking about carbon capture and storage, I think. Is that right?
Absolutely.
I love that. It was one of those subjects that we touched a little bit on this morning. A few people sort of brought it up, but it's one of those terms. It's sort of quite an unusual term. If you're not familiar with what carbon capture is, I'm delighted to say that you're going to be explaining all about it. So I'm going to hand over to you. And I think if we get any questions coming up in the chat box, would you like me to throw